Hello, hello, hello. Candid आज एकदम relax.
Good morning, Patil sir. Welcome this session. Sir, you are the co-host now. You can unmute yourself. We'll start within 2 minutes.
Hello, hello. Shall we start, sir? Vishwanath Patil. Vishwanath Patil, sir, kindly share your screen. Good morning to one and all. I, Dr. Pooja Shinde, am pleased to welcome you all on behalf of John Wilson Education Society's Wilson College Autonomous to the second day of this interdisciplinary conference on scientific approaches for sustainable environment in collaboration with University of Mumbai. We are delighted to have you all here, whether in person or virtually, as we continue our journey towards fostering sustainable practices through scientific approaches and innovations. So we will begin our day with our national anthem. I request all of you to rise for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा, विंध्य हिमाचल यमुना गंगा उच्च उच्छल जलधि तरंगा, तव शुभ नामे जागे, तव शुभ आशीष मागे, गाहे तव जय गाथा, जन गण मंगलदायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे जय 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 हे.
Thank you all. Kindly take your seats. Before continuing with today's session, I would like to mention a special thank to Organica Biotech for sponsoring this conference. Adopting sustainable approach is not a merely suggestion, but necessity dictated by imperatives or time. It is called to action. It is commitment to reshape our relationship with the environment. As we navigate the complex challenges of changing world, embracing sustainable practices will lead us to a future with harmony between humanity and planet. This could be the reason why United Nations has also recognized 17 goals for sustainable development, all of which are ultimately connected to this. It is critical for us, teachers, professors, scientists, to cultivate consciousness, create awareness, build and share innovations for sustainable development. We have organized this conference keeping this goal in our mind. I would like to briefly review yesterday's proceeding. Inaugural ceremony of the conference was followed by keynote address by Dr. Ganesh Kamath, founder and director of Organica Biotech, on environmental protection and sustainability. After keynote address, the first technical session was conducted by Dr. Sushanta Kundu sir, COO, Excel Innovation Center, Mumbai, on managing and recycling the waste. We had second technical session by Dr. Gunjan Prakash, Associate Professor at Center of Energy Biosciences, ICT, Mumbai, on biotechnology linkages to safety, environmental protection, sustainability, and economic growth. All these speakers were truly very much informative and inspiring. They have shared their effective, efficient, and novel approaches to deal with contemporary environmental issues. I am sure that all of you must have enjoyed the intellectually stimulating technical sessions. Post-lunch, the sessions were held for poster and oral presentations. So today, on the second day of the conference, we shall be having 4 technical sessions before lunch, and presentation shall follow post-lunch. Without further ado, we will begin with our technical session. For first technical session, we have with us Dr. Vishwanath Patil, Chairman, Board of Studies of Chemistry, University of Mumbai. Sir will be talking on recycling of lithium-ion batteries for circular sustainable development. This session will be chaired by Dr. Abhijit Kadam, Assistant Professor, Department of Chemistry, Wilson College, Mumbai. According to a survey conducted by Stanford University scientists, Dr. Abhijit sir is among top 2% scientists in the world for consecutive 3 years. Now, I request Dr. Abhijit sir to introduce our today's speaker and chair the session.
Thank you. Hello. Thank you, Pooja madam, for nice introduction. So, very good morning to one and all present here. It's my pleasure and privilege to introduce our invited speaker for the national conference, Professor Vishwanath Patil sir. He is currently working as a professor of Chemistry in the University of Mumbai. He is a director of National Center for Nanoscience and Nanotechnology, University of Mumbai. Professor Patil completed his PhD degree in 2002 in inorganic chemistry from the Institute of Science, Mumbai. His research area interest includes water-soluble polymers, light-emitting polymers, nanochemistry, polymer nanocomposite, invisible barcodes, polymer nanocoating, self-healing polymers, antiviral coating, recycling of lithium-ion batteries. He has successfully guided 16 PhD students, some of them working in the abroad as a postdoctoral study. Currently, 7 students are pursuing PhD under his valuable guidance. Professor Patil has published more than 17 international research articles in the International Journal of Reports. I would like to tell one journal mentioned here, Advanced Material, having 33 impact factors. He has 33 patents filed, published, and granted. He has completed 4 research projects for different funding agencies, including DRDO, Industry, DST SERP, and UGC. He has delivered 78 invited talks at various workshop conferences and symposiums. Professor Patil is a recipient of various awards such as Best Researcher Awards at University of Mauritius, Dr. Arvind Kumar Memorial Award for Best in Scientist in Chemistry by Indian Council of Chemists in 2019. Sir is also a fellow of Maharashtra Academy of Sciences. He has also awarded as Best Teacher Award University of Mumbai in 2019. He is working as a chairman, Board of Studies in Chemistry, University of Mumbai. Member of Boards, Innovation, Incubation, and Linkage, University of Mumbai, appointed by Vice Chancellor of the University. Member of Board Studies in Chemistry at Pratap College, Jagaon. Member of Board Studies in Chemistry in Mumbai at various colleges like Kirti College, CKT College, SIWS College. He has many national and international collaboration such as Harvard University, USA, Swiss Federal Laboratory, Switzerland. Few universities are from China, and also he has various national collaboration as NCL Pune, IIT Mumbai, other departments of University of Mumbai, and various colleges. So with this, I would like to invite Professor Patil, sir. Sir, over to you, sir.
Thank you very much, sir. Hope I'm audible. Am I audible? Can anyone please unmute and say, am I audible or not? Hello, hello, hello. Abhijit, sir. Okay, thanks.
Yes, sir.
Yeah,
Yes,
I
sir.
got a message from chat box that I'm audible.
Yeah,
Okay.
you are audible now, sir, and you are visible.
Yeah, thank you, Abhijit sir, for kind introduction. I think it was very long introduction. I thought you can just say my name so that I can introduce myself later. Okay, at the outset, I thank Wilson College for inviting me here, especially Principal of Wilson College, Professor Annani Karji ma'am, and the convener of the conference, Professor Anuradha Pensi ma'am, and the co-conveners of all co-conveners of the conference, and HOD, Professor Parbat sir, and secretary of this conference, that is Abhijit Kadam sir, and all faculty from the chemistry department, all students of the chemistry department, and the participant. Good morning, one and all. As the theme of the conference is, I think I should share my screen, right? First, yeah. Hope the screen is visible.
Yes, sir. Your screen is visible to us.
Okay. Okay. As the theme of the conference is based on sustainable environment. So I thought I can talk on the sustainable development or the related work that we are doing in our laboratory. Um, Basically, I'm a polymer chemist, and I always say that polymers are wonderful materials. I think I can take this screen down, or rather, I can hide it. I don't know how to hide it. Okay, I can put here only. Okay. I always say that polymers are wonderful material. See, the conference theme is based on the sustainable environment, and now you will wonder that why he's saying that polymers are wonderful material. But if you are preparing polymer in the laboratory, and if you are applying those polymer for solving many social problems, and if you are using this polymer with a certain responsibility, I think polymers are wonderful material. As I show this slide everywhere, wherever I go, we started with the Stone Age. Our civilization started with the Stone Age, and the man at that time was using stony materials for his safety, for kitchenwares, for everywhere. He was using the stony material. So that era was called as Stone Age era. Later on, he found alternative bronze, which was comfortable and sophisticated to him. Whenever stony material was broken, it was difficult to join those two atoms, which were broken atoms. But in case of bronze, it was not. It was easily possible to connect those atoms. So he went with the bronze, and that era was called as Bronze Age era because all stony materials was replaced by bronze. Later on, it went to the Iron Age because every bronze material or bronze item were replaced by iron because it was a sophisticated and cheaper than the bronze. After that, we found polymer as a cheapest material and the very lightweight material, and we moved with the polymer. And nowadays, everywhere we are using polymer, like laptop, phones, or even the clothes. These are made from the polymer, and we say that we are into the polymer age now, but we are not having alternative to the polymer till today. So it is difficult to live without the polymer, and it is very difficult to give up the polymer. So I say that polymers are wonderful materials. Okay, so polymers are having a lot of applications. Since morning to evening we are using polymer, and in our research also we are using the polymers. Like, for example, invisible barcode technology. We use polymer for this technology. As sir mentioned during my introduction, that we invented this technology in 2018, and this technology was all about we prepared a polymer sheet, that is epoxy polymer. The middle image is of is invisible barcode technology, where we prepared this sheet. And since this sheet is a cross-linked polymer, and if you are putting a drop of gold solution here, it goes inside and it interacts with the nitrogen present there, and it gets converted into nanoform. And whenever gold is getting converted into nanoform, it becomes invisible, and you can visible those nanoparticle by putting light or by focusing the light of particular wavelength. This technology we published in a very famous journal, Advanced Material, which is having very high impact factor, as sir mentioned during the introduction. And second one that we prepared in our laboratory are antiviral nanocoating. It is again based upon the polymers. So we prepared the polymer based antiviral nanocoatings for the safety of the doctors during the COVID-19 pandemic. And this work was in collaboration with CCMB Hyderabad, that is Center for Cellular Microbiology, who actually analyzed our samples on the COVID-19 virus directly. And we found that these antiviral nanocoatings are having more than 100% efficacy. And it was only one sample that time that showed this much higher activity. And these two technologies I have already presented in Wilson College, so I will not speak on those. But yes, this third image is of battery that we actually prepared in our laboratory from old batteries, and that is the recycling of lithium ion battery. And we also studied the electrochemical behavior of this battery, and we found that this battery is having promising results than the original battery. So that is what I will talk about today. So let me go ahead with the next slide. Okay, yeah. So I hope you can see the image. That is the Center for National Center for Nanoscience and Nanotechnology, which is located in our Mumbai University. And currently I'm holding the director position here. Six government grant that we received, and more than 100 crores instruments are there in this center. And people here or researcher here are doing their research on the nanoparticle. They are preparing nanoparticle. They are using this nanoparticle for a variety of applications. If anybody is interested or they are interested in using the facility, they can directly come to me and they can use those facilities. Currently, most of the instruments are non-working condition, but yes, within 1 month, we are in the process of starting these instruments. Okay. Now, everybody says that the nano, if out of 10 researchers, 9 researchers are doing their research in nano. So why nano? Because if you are converting larger thing into nano, they changes the property. They shows different property. For example, we have a carbon material that is a graphite. Graphite is very soft. If you are using it in the form of pencil, you can easily put a line on the paper. So soft it is. But when you are converting the graphite into nanoform, nanographite, it becomes very strong, more than steel, and it is lighter also. Okay. And copper. Copper is a hard material. Everybody knows. We are using copper in the wire. So copper is a very hard material. If you are converting copper into nanoform, it becomes elastic like rubber. You can stretch it like rubber. So since materials are changing their property when they are converted into nanoform, people are more interested to prepare nanoparticles. Okay. So these are some applications that where we can use nanomaterial. Being a nano person, I always say that these are the applications. These are according to me. You may be having different mind application in your mind, but according to me, these are the applications. For example, white hairs. People hide their white hairs. Like college students hide their white hairs by putting a say dye, hair dye. So can we have permanent dye to the white hairs? Can we have some nano oils? You can put it on the hairs and your hairs will be permanently black. So this kind of research you can do in a laboratory. Food packaging. Can you keep your food fresh so that the soldiers sitting at Siachen border or say the Leh Ladakh border, they can get fresh food. Because when Kargil war was going on that time, we heard that the soldiers were getting food that was prepared 3 days before, and the food was of poor quality. So can we keep that food fresh so that they can get the fresh food? By preparing some packaging material, by preparing some nano packaging material that can keep the food fresh. So this kind of research I think we can do. Fuel research, fuel prices. The prices of the petrol are getting increasing day by day. Can we have some nano petrol and so that we can use it instead of the petrol that we are using today? So these are some research that I can this research topic that I can give you for doing your research, because most of you are MSc students, and in future you might be thinking about the research, so you can go this direction. So do the research that is beneficial for the mankind, that is beneficial for the society, that is beneficial for the environment. That is why the Wilson College has organized the conference, which is based upon the environment. Okay, so let me go to the my topic now: recycling of lithium-ion battery for sustainable development. Now, where we are using lithium-ion battery currently? We are using lithium-ion battery in the mobiles, in the laptops, in the electric vehicles, and everywhere, right? So lithium-ion battery is useful nowadays. I'm focusing only on the electric vehicles right now, but later on you can use this technology for any battery, any lithium ion battery. Now why people are buying electric vehicles, why we are interested in electric vehicle? First of all, let us see the background and then we can go actually what we did in our laboratory. Now why electric vehicles? Because we are more concerned about the environment, we are more concerned about our mother earth. right? We want to save our environment. So we are more interested into the electric vehicles. Apart from that, there are few advantages. For example, the electric vehicle is a very good alternative for the petrol vehicles because they are not giving the carbon black or the pollution. Electric cars are propelled by electric motors. You can charge that electric battery and then you can run your vehicle. And do not produce exhaust gases. It helps to reduce the carbon footprint. It is more environment friendly. It is more efficient. It is sophisticated, lower maintenance. Further, we can see more advantages. It is low maintenance, low registration fee. If you are purchasing the electric vehicle, you will get this subsidy in the registration fees. Road tax, lower road tax. Don't have gears. Everybody um, can drive the electric vehicles. Those are having the habitual with the bikes. They can easily use those electric vehicles. No complicated controls. Fast charger can charge. Charging is an issue with the electric vehicles. It requires a lot of time to charge. But nowadays, fast chargers can charge the vehicle in 2 hours. It helps reduce noise pollution. That is most important. If electric vehicles are going besides you or uh, nearby you, you will not notice that the electric vehicle has gone. So smooth it is. So therefore, everybody is going to buy electric vehicle nowadays. And yes, we are looking forward for Indian transport, and we must wish to them now. Now, I'm not seeing actually the screen. Okay. Anyways, I will manage. I will try to manage. Okay. So what is the impact after 10 years, by the way? Because everybody is trying to buy electric vehicles and all electric vehicles will be on the road. And what impact we are creating after 10 years? Let us see. More than 140 million electric cars are estimated to reach the road by 2030. So guys, please focus on these numbers. The annual Indian lithium-ion battery market is expected to expand 37.5% from 2.9 gigawatt hour in 2018 to 132 gigawatt hour in 2030. An industry analyst says that China alone will generate some 550,000 metric tons of lithium-ion batteries by 2030. The worldwide number will hit more than 2 million metric tons per year. The creation of massive quantity of battery results in generation of huge amount of trash. Why? Because lithium-ion battery is having some lifetime, maybe 4 years, 5 years, max to max 7 to 8 years. After that, you are throwing that lithium-ion battery into trash because you are not thinking about recycling of that lithium-ion battery. Nobody is thinking about recycling of lithium-ion battery today. Everybody is thinking to enhance the battery life, to enhance the capacity of the lithium-ion battery and all. So nobody is thinking about the lithium-ion recycling. That is the sad story. Now, basically, what is the lithium-ion battery? We are using mobile phone. Mobile phone contains lithium-ion battery. At least we should know what exactly the lithium-ion battery. It is a secondary battery, right? There are two types of battery: a galvanic battery and electrochemical cell, galvanic cell. That you must be knowing. And into the galvanic cell, we are again having primary battery, secondary battery. Primary, it is not rechargeable, whereas secondary battery is rechargeable. So this is actually the block diagram of the lithium-ion battery. You can follow the cursor. It has a two compartment, major two compartment. One is for cathode and one is for anode. So guys, please wait. I am getting a phone call. I'll take that. Hello. सर मी लेक्चर देतोय विल्सन कॉलेजच्या कॉन्फरन्स मध्ये. Yes. Yes, yes, please. Yes, 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 yes. Thank you. Sorry for interruption. Yeah. So these are the two compartments. Anode compartment, mostly it is a graphite, porous graphite, and cathode compartment, mostly it is a lithium ion. lithium salt. And it is these two compartments are separated by polymer separator, and we have a two current collector here. One is for cathode and one is for anode. It is for cathode, it is mostly say aluminum, and for anode it is mostly say for example copper or something. Okay. And the lithium ion, when you are charging the battery, the lithium ion moves from cathode compartment to anode compartment. When all lithium ion are transported to this compartment, you said that your battery is fully charged. Now, during the discharging, the from anode compartment, your lithium ion moves toward the cathode compartment to back their original position through this polymer separator, and they release the electron, which is in the form of current. This is the way mechanism of the lithium ion battery is. And since the lithium ion is transporting from anode compartment to cathode, cathode compartment to anode, it is said the battery is also called as rocking chair battery. I hope idea is clear what is lithium ion battery. Nowadays we are using lithium ion battery for these applications. I will not go into the detail of those applications. Okay, what are the contents of the lithium ion battery? Now, percentage wise, if you see, 22% is a graphite. Quickly I will show. 31% is the cathodic compartment, that contains lithium, then cobalt, then maybe aluminum, then nickel, then copper. You can say all this contains. Then these are other percentages, like 15% electrolytic solution that can be used, 3% polymer separator that we use, and 8% aluminum. These are the current collectors. Copper 17% current collector. Okay, the most precious metals are here in the cathode, that is lithium, nickel, cobalt. So these are the precious metal that we are using, that are 31%. Okay. Now these are the 5 different chemistries, lithium ion battery cathode chemistry that we are using nowadays. I think I will keep this down because I'm unable to read the screen actually. Okay. Okay, lithium ion battery cathode chemistries. The lithium ion battery that we are having is based upon these chemistries nowadays. Researchers are focusing their research on this kind of battery. I will just give introduction of one lithium ion cathode chemistry. For example, this lithium, nickel, cobalt, aluminum chemistry. It is called the NCA lithium ion battery. NCA means lithium, nickel, cobalt, aluminum chemistry. Lithium is common. Now, when you are preparing battery of this material, the cost of the battery is very low. It is cheaper, economical. Lifespan is also very high. Specific energy is also very high. Specific power is also very high, but safety wise, it is not as up to the mark. So it can burst anytime. So people are now avoiding the preparation of this kind of battery, and they're focusing on other batteries like nickel, manganese, cobalt, and manganese spinel LMO battery, then LTO, that is lithium titanate battery, and lithium phosphate battery. The last two chemistries are nowadays widely used chemistries, and most of the batteries are based upon this. Okay, next slide, let us go. Current cost of the lithium ion battery material. Of course, we are depending upon the foreign countries for the material that we are using in the lithium ion battery fabrication. So we are not having material that is from India that can be used in the lithium ion battery. So always we are purchasing it from the abroad, and accordingly the price of the lithium ion battery goes high. Okay, so while preparing this lecture, I thought I will collect the data from the Google also, why the lithium-ion battery is recycling is very important. So these are some articles that for, as I said, for raw material we need to depend upon the foreign countries, and reservoirs in the nature are less. So we need to think about the recycling of the lithium-ion battery. So these are some articles that world needs to crack battery recycling fast. Will battery recycling be ready when all these new electric vehicles battery will die? Okay. And few more, lithium-ion battery need to be greener and more ethical. Okay. Now what currently we are doing with the lithium-ion battery? Okay. So far, 4-5 years are not over, so lithium ion battery that are there in the electric vehicle are working. But after a few days, we need to throw them into the trash. No, what we are exactly expecting that you will throw those trash into the environment. Everywhere you can find the electric vehicle's battery is lying, or it may be in the environment, it will be buried into the soil, and it will create hazardous to the environment. So it will be very dangerous to the environment, and that time we can think about the environment. So it creates, when you are putting it into the land, it creates hazardous gases, dust particle, fire, and when you are processing it or you are burning it, it also creates toxic gases into the environment. Or if you are throwing it into water, it may create hazardous metal oxide, electrolytes, carbon compound into the water. So it will pollute the water also. So in all, overall, you are polluting air, you are polluting soil, you are polluting water wherever you are putting this electric vehicles battery. Okay, and globally there are no standards for disposal of the lithium ion battery. इसको कैसे dispose करना है, कौन कैसे dispose करेगा, there are no standards. And only 5% lithium ion batteries are recycled worldwide. So no, as I said earlier, nobody is thinking about recycling of this lithium ion battery. Researchers are completely focusing to enhance the capacities of this lithium ion battery. So we thought that if others are not thinking, can we think about this direction? Can we do some research in this direction? As a researcher, I always ask the question before starting the research: can we work in this direction? Can we develop the cost-effective method to recycle the lithium-ion battery? Because whatever 5% lithium-ion batteries are recycling today, those recycling methods are not cost-effective. So people are not thinking about that direction. So can we give some cost-effective method so that people can work in this direction? Can we give a lithium-ion battery that will have a very high electrochemical performance? And would it be safe if we are recycling it? Would it be safe? Or can we use some nano materials, nano content so that we can enhance the capacity, enhance the performance of the battery? Okay, so those questions we asked ourselves and we started working in this direction. And still there are few questions, there are few challenges which were before us. Recycling of lithium ion battery would help to reduce the dependency of high cost battery materials. As I said, we are exporting the material for fabrication of the lithium ion battery from abroad. So it will reduce the dependency of those countries. It will improve the security of the supply chain. It will reduce the human environmental impact brought by these batteries. Of course, it will save the environment. What are the problems associated with the lithium ion battery? When we when we think that we can recycle the lithium ion battery, so these are the challenges before us. Why we try to find out the reason why people are not thinking about recycling of the lithium ion battery. That is the question. Because as I said, in the cathode, cobalt is used, nickel is used, lithium is used. Nowadays cobalt free batteries are coming, nickel free batteries are coming. If these batteries are not containing the precious metal, who will recycle those batteries then? Because the aim of recyclers is that they can get this precious metal and they can sell this metal, they can get the market then. But if battery is not containing cobalt, nickel, who will recycle those batteries then? What is the benefit of this recycling then? Graphite is people are not concentrating on the graphite because it is low cost material. And who will recycle the graphite then? Okay, and recovered graphite, if you are recycling the graphite will not give you the electrochemical performance that battery is needed. Okay, so these are the reasons why people are not thinking about the recycling process, because it is not a profitable business for them. Okay, so currently, whatever 5% batteries are recycled, these are the processes by which they are recycling. Deactivation process. First of all, you need to deactivate the battery, because whenever you are opening the battery, it may get explode. because of the charge, you need to discharge that battery first. Then mechanical treatment, you need to crush that battery, you need to sort that battery, sieve that battery parts, and then follow the metallurgy and hydrometallurgy processes. All stages, all processes are having advantages, disadvantages. We will not go into those parts. If you are interested in recycling of lithium battery, you can read out those part again, or you can contact us so that we can give you the detailed information. Okay, what we did in our laboratory. Okay, so now I'm moving the cursor, you just follow the cursor. This is the conventional recycling process for the lithium ion battery. People are taking spent lithium ion battery, they are dismantling it, and they are treating it with the acids. They are treating this dismantle part with the acid, and the acid dissolves everything. Now you can filter the solution and you will get the residue which contains the graphite, and in the filtrate you are getting the precious metal, that is the cathodic material. Now graphite material they are throwing straight away into the dustbin, whereas they are interested in this noble metals so that they can get the market or they can get the money. This is the overall recycling the people are doing. Now what we did, we are not throwing this graphite, we are utilizing this graphite for further manufacturing of the battery process. We are also using this for preparing the cathodic material. So for whatever work I am presenting here, it is depending upon this anodic material, that is graphite. So far we have not successfully recycled these materials. Rather, we have successfully recycled, but we have not received the electrochemical performance of the battery that we have prepared with this metal so far. So I would be concentrating on anodic part. What we did, we took this spent lithium ion battery, we dismantled it as per the conventional method, as used in the conventional method, and then we crushed the material and we treated this material with sulfuric acid and phosphoric acid. The ratio is also given here. So we call this as a modified Hammers method. And along with that, we also add KMnO4 and KMnO4 so that you can get the graphene oxide, which is in the form of reduced graphene oxide. So we are not getting graphite directly, we are reducing the graphite. Now, graphite, instead of graphite, we often reduce graphene oxide by treating this way. And further, you can treat this reduced graphene oxide with triphenylphosphine or BATiO3 nanoparticles so that you can enhance the capacity of the material that you are getting. If you are using this kind of material, you will get very high electrochemical performance. That is what why our aim was. So this is how we recycle the anode of the lithium ion battery. This is the process. First, you can take this battery, you can crush those batteries, and then you will get this kind of material. You can leach with the acid and you will get this kind of residue, that is graphene, reduced graphene oxide. So it's black in color. Now, if I'm comparing this reduced graphene oxide with the graphite, the cost of this reduced graphene oxide is 500 milligrams cost is 33,255. 50 मिलीग्राम का cost is 33,255, and for 1 gram the cost is 53,857. Means I can make the market here also. If I am recycling the lithium ion battery, if I am dismantling the lithium ion battery and putting it into the acid, and if I am filtering it, if I am getting this material which is equivalent to the price of the gold, I can get the market, I can get the money here itself. Okay. But being a researcher, I'm not doing this. I'm going ahead. I'm treating this reduced graphene oxide with the help of triphenyl phosphate and with the help of BATiO3 nanoparticles so that I can get more conductivity and more thermal stability to this material. So this is how we can treat, and what is the alternative, what is the final material that we are getting. We have also analyzed this material by variety of the techniques that are available. For example, XRD, Raman, bait. Now, XRD, we analyze the samples with by XRD, pure BaTiO3 nanoparticle, then reduced graphene oxide, which is doped with the phosphorus, and then combined material. But here we found that the reduced graphene oxide, which was doped with phosphorus, was not shown here. So we were worried about this. So we went for the Raman, and we got the proof that yes, phosphorus is still there, and we can go ahead with this material. And then we analyze the porosity of the material. We characterize this material with the same, you can see the circular nanoparticles of BaTiO3, and which was there deposited on the sheet of the reduced graphene oxide. This is the reduced graphene oxide sheet, and this is the material, combined material. Here you can clearly see the circular nanoparticles that are deposited on the sheet, that is a reduced graphene oxide sheet. TAME, then HRTM, all analysis was done, and XBS was also done for this. And then we confirmed that yes, we can use this material for the fabrication of the battery. So we went for the battery. We are not having facility to make battery, so we requested ISER Ogles lab, and Ogle sir said that yes, you can fabricate the lab you can fabricate the cell in our laboratory. So we took their help. One of my PhD students is working with Professor Ogle, so it was very easy for us to access his lab, and we requested them, and they fabricated the cell for us. So this is the coin cell they fabricated for us, and this is the process that they use for fabrication of this battery. They also analyze the electrochemical performance of cell, and they also chemical cell performance of the cell with the others. What data we received? The electrochemical performance is um, capacity of that, and it is found to be 740 and 824 respectively. 740 and 824 milliampere hour per gram respectively. And if we compare it with the graphite battery, it is 372, means it is exactly double than the graphite battery. And also the specific capacity was very high, 428. Current density was also very high, and this is actually the cell that we prepared. I can take this to here. So we prepared, as we discussed earlier. This is the separator, polypropylene separator that we used, that was dipped into this lithium hexafluorophosphate. And the lithium cathode that we use is purchased from the market directly, and we fabricated the battery. So this ISER Pune people did this job, and they fabricated the battery. And this is the movement of the lithium ion. So during the charging, the lithium from this sheet goes to this side. It deposited into the porous part of this anodic material, and then during the discharging, it goes from this to this lithium compartment again. Okay. Okay. Then uh,
Hello, sir. You are not audible. Patil, sir, can you hear me?
sir, कधीपासून hello.
Yes, yes, sir. You are now visible. Am I audible?
Sir, I exactly don't know when I lost my connection. Can you please tell me? I was here.
Here only, sir. Here only. Impedance.
Okay. Okay. So as I said, the electrochemical performance was very good. Solution resistance and charge transfer resistance was extremely good in comparison with the other batteries. Other batteries like containing graphite, and graphene and graphene. So we said that we can use this material that is recycled from the lithium-ion battery for fabrication um, of the batteries. Now, what we did here, our aim was recycling the lithium-ion battery, but we not only recycle the battery, but we transform this trash, we transform this lithium-ion battery into the high-performance electrode material or high-performance lithium-ion battery. So uh, in Marathi we have a kahavat that आंधळा मागतो एक and देव देतो दोन. In that case, the thing happened with us that we were trying to recycle the lithium-ion battery and we were trying to manufacture the lithium-ion battery with that, fabricate the lithium-ion battery with this recycled material. But the recycled material was so good that it has excellent electrochemical performance. Okay, let us move ahead. So conclusion is that we can easily prepare cost-effective. We can easily demonstrate the cost-effective way of recycling of the lithium-ion battery, and everybody can do this in their lab. And we can enhance the performance of this electrochemical material by uh, by adding some nano parts by nano content into that, and we can then compare the electrochemical performance with other batteries. So we say that this recycling process is completely based upon the green chemistry principle. It reduces, recycle, and reuse. So that is what we say. We published this technology, this recycling process in very famous journal, that is Sustainable Materials and Technology, that has impact factor 10.68. When we published this work in this paper, uh, we got a call from the university that you can give this project to the Avishkar, to Animation, and so on, all this competition. And we got a gold medal for animation 2023 for this work. Also, we got a gold medal for Avishkar for this work, and we got appreciation from all authorities of universities and state government. You can see my student Roshan Rane presented this recycling work in front of the Chief Minister of Maharashtra, Eknath Raoji Shinde, and the Chancellor of all the universities, that is Rajyapal Bhagat Singh Koshari ji, and they appreciated this work. Yes, of course, if you are doing good research, you will get appreciation from all over, and we got appreciation from
Sir, your voice is breaking.
name.
Sir, you are not audible.
I think again my connection lost. Okay, I will have to share the screen again. I don't know when I lost the connection now.
In the appreciation
Okay.
slides.
Okay, so before this I can go. Okay, I think I was here. Sir?
Before that.
Here.
Before. Yes, sir. You are here.
Here I was. Okay,
Next
so
slide,
we published this technology in a very next slide. Here.
Yes, sir.
Here. Okay, so successfully we developed the recycling method, which is beneficial or cost effective, and
Sir, this
you
slide
can
is done.
enhance the whatever.
Sir, next three, sir.
Okay, okay.
Next.
This was also done.
Next.
Okay, so this is the okay. Yeah, babe.
Ha.
Okay, we got appreciation from all fronts. My student who did this work in lithium ion battery. Actually, this is his PhD topic, and he presented this work in front of the Chief Minister of Maharashtra, Eknath Rao Shinde, and the Bhagat Singh Koshyari, that is Rajyapal, Governor, and Chancellor of all universities of Maharashtra. And these are my students who actually presented this work in Ambition and um, Avishkar 2023, and they received a gold medal. And we were into the media also. After doing uh, the work that is uh, useful for society, that is useful for mankind, you will be into the media. People will talk about you. So same thing happened with us also. Whenever we are doing this kind of work, we are into the media. Now this time our university has took the press conference, and they had given this news everywhere. So it started from Times of India and all other um, print medias. Okay, so I hope you can get motivation from this, so that you can do wonderful work in your laboratory also. Now, what are the future approaches? What we are doing? Recycling is okay. Now we did recycling. We set the procedure for recycling. Now, what exactly we are doing? Now, further, one step ahead, we are now trying to prepare a recycle-friendly lithium-ion batteries. Okay, now you will ask me what is exactly the recycle-friendly lithium-ion battery. Now, recycle-friendly means once you are recycling by using our technology, no need to follow the big steps for recycling again. No need to follow the bigger steps for fabrication of the lithium-ion battery. You can put this battery into water, or you can put this battery into ethanol. Once it is if you are throwing this recycled lithium ion battery into trash, before throwing you can just put into water, or you can just put into ethanol. It will be completely dissolved, and you can just put it into the mold. That will be your lithium ion battery. So this sort of battery we are trying to prepare, and it is called as recycle friendly lithium ion battery, so that even layman can recycle lithium ion battery at home. Okay, and next step, we are also trying to prepare flexible lithium ion battery in our laboratory, so that you can convert the lithium ion battery, present lithium ion battery, into any shape. Like, for example, the lower part of the electric vehicle is completely packed with the lithium ion batteries. Okay, so that part will you can make a free, and uh, you can use the entire body of the electric vehicle as a lithium ion battery. So this sort of technology we are now trying to develop in our laboratory, and success we are now I can say that the 50% success we already got in flexible lithium ion battery. So I think I will try to stop here, because there should be some time for discussion also. But I think if time permit, I can show one video before that, so that what exactly we are having in Nano Center. But before that, let me acknowledge my student, those who are doing working hard in our laboratory for doing good research, and my collaborators and the funding agencies that is giving us fund for doing this kind of research. And I also thank all my department and Nano Center for providing me the facility. So before concluding, I think I can show you video if all permits. Just tell me if it is running
Yes, sir.
properly.
Yes, sir. You can show, sir.
Is 1.5
We
minutes.
have time. Sir, you are not showing audio.
Sir, I don't know why audio is not in, but anyway, it is the music. You can just see.
Okay, okay, sir.
Yeah. Yes, here you can find it is actually the human hair, and on the human hair we have carved the Rajabai Tower. You can just check. Yeah, thank you so much. If
It was a really great
you
talk,
have
sir.
any question, please ask me. I would be very those questions, especially from the MSc students.
Now the session is open for the discussion. If participant has any question, she can ask in the chat box.
First of all, I'm extremely sorry for technical glitch because Wi-Fi was not stable here.
There is no any questions.
So, let me
There is
check in
one
the.
question in the chat box.
Yeah, that is what I'm checking.
Lithium is a toxic, sir. How you are dealing with it?
Yeah, lithium is toxic. How you are dealing with it? So far, we have not directly interacted with the lithium. We have purchased the lithium strip from the market, and we use that lithium strip as a cathode. We have not dealt with the lithium directly here. Okay, and as per as I mentioned earlier in the talk that We are not so far into the recycling of the cathodic material that contains the noble metals like lithium, then cobalt, then nickel. Okay, we are into the recycling of the anodic material that people are throwing while recycling this LIBs, that is graphite that we convert into reduced graphene oxide. So that is what we are doing into the lab. Okay. But yes, any other questions, sir?
Sir, I have one question.
Yeah,
What
yes,
is the
sir,
solution for the safety of?
yes, sir. Somebody said that lithium is explosive, and when we add it into water, it is explosive. And how can you recycle it? So lithium ion that we are using is not into the bulk concentration. It is very low concentration, and it is in the form of salt, not a pure lithium. Okay, like sodium is also explosive, but we are having NaCl and other things so that we can easily put into water. Okay.
So next question is there. What is the composition of
Yeah.
effluent that come?
Yeah, the composition of effluent that come out during the recycling. What is the composition of effluent? Effluent, I guess it depends upon what kind of battery you are using. As I said, there are 5 lithium-ion battery cathode chemistries. So it depends upon what kind of lithium battery chemistry you are using. So it depends upon that. Yeah, Abhijit sir was asking something.
As electrical vehicle catch the fire, so what would be the safety precaution we should take?
Yes, sir, as I mentioned earlier that uh, out of the 5 battery chemistries, some of the battery chemistries were actually the batteries prepared from those battery chemistries were not safe. So most of the time when the electric bike came in on the road, so that incidents were happening earlier. But nowadays the battery is not catching fire because we have changed the battery chemistries. We have worked on that part and we made the battery safe. So unless and until you are not catching with any incident, battery will not catch fire. So that those batteries are made safe now.
Thank you, sir. So if there is no question, then let me offer the vote of thanks. On the behalf of management, principal, convener, co-convener, and organizing committee members of Interdisciplinary National Conference on Scientific Approaches for Sustainable Environment, I would like to thank Professor Vishwanath Patil sir for accepting the invitation despite your busy schedule and sharing your valuable insight on such an important topic of recyclation of lithium-ion battery into value-added anode to promote circular sustainable development. The topic is utmost important because of 12.7 million tons quantity of waste from spent lithium-ion battery into the directly landfill. It creates secondary pollutions. So, sir has presented cost-effective and viable method for recyclation of graphite from waste battery and fabricated into in situ barium titanate phosphorus doped RGO anode materials and thereby adding values to the recycling process for the circular sustainable development. Sir started his pitch with the what is polymer and wonderful properties of the polymers, what is nanoparticles and what are the use of the nanoparticles, why nanoparticles are so important, and sir is also summarized different methods for the recyclation of lithium-ion batteries, and out of which sir has recycled graphite. So sir is now going to focus on the metal like lithium, cobalt, and nickels, because these are more toxic metals. So thank you so much, sir, for such an enlightening talk. It is indeed really privilege and honor to listen to you. I strongly believe that our participation have benefited with your knowledge and expertise. Hope to interact with you again in the future program. And student, I am requesting you fill the feedback form whose link is posted in the chat box and on WhatsApp group. Thank you, sir. Thank you one
Thank
and
you
all
so much,
for
sir.
joining this.
Thank you so much, sir.
Vishwanath Patil sir, especially thanks because you are the coordinator in the refresher course, and in the busy schedule also you took the given the 1 hour for our conference. Thank you very much, sir.
Thank you, sir. Thank you, sir. Thank you, one and all. So, may I leave now?
Yes, yes, sir.
Okay, bye bye.
Thank you, Dr. Vishwanath Patil, sir, for giving deep insight on tracking the environmental issues that can emerge through use of lithium-ion batteries, challenges in recycling the batteries, and the method through which recycling of batteries can be made profitable. Thank you, Dr. Abhijit, for chairing the session. There will be a 5-minute break before the next session. I request participants to be online. The same link can be used to join the next session. Thank you. Hope you all are back now. We are beginning the next session. We are privileged to have with us Dr. Vivek Patkar, researcher and ex-operation research specialist at MMRDA, as resource person for the second technical session. I request our convener, Dr. Anuradha Pense ma'am, to welcome Dr. Patkar sir with a small token of love. Thank you, Anuradha ma'am. This session will be chaired by Dr. Ashish Usgare, Assistant Professor, Department of Chemistry and Vice Principal, Wilson College. Being an active researcher, Sir has published many articles in reputed journals. He also has major and minor projects to his credit. I would like to request Dr. Ashish Sir to introduce our speaker and chair the next session.
Thank you so much, Dr. Pooja. A very good morning to everybody. It is indeed my proud privilege to introduce this session's resource person. I quote, "There is no need to boast of your accomplishments and what you can do. A great man is known. He needs no introduction." This quote befits our resource person. Dr. Vivek Patkar holds BSc Honours degree in mathematics, a subject which many are scared of. He has to his credit, his post-graduation and PhD in operational research and is now an independent researcher. Dr. Patkar, in his long career with the most famously known MMRDA, that is Mumbai Metropolitan Region Development Authority, followed an academic stint at the Institute of Chartered Financial Analysts of India, that's ICFAI, Business School, Mumbai. And he has used several mathematical tools, models, remote sensing, and geographic information system technology tools, and advanced research methods for land use planning, transport, and urban management. The field of library and information science is also an area of his study. A large number of institutions in the country invite and consult him for their research-related guidance and publication activities. Sir is also a resource person for many orientation and refresher programs. To his credit, Sir has 16 books and friends, over 500 publications spread across a number of subjects and formats. I think he deserves that round of applause. Yes. He continues to serve on the editorial board of many international journals through Marathi Vignan Parishad, Mumbai. He is engaged in popularizing science and mathematics among all sections of the society. Sir, we welcome you for this session on this interdisciplinary national conference on scientific approaches for sustainable environment. Ladies and gentlemen, I present to you Dr. Patkar.
Thank you very much for the introduction. Good morning, the chairperson, the staff of mathematics and other departments, researchers, students, participants, online, offline. I express my sincere thanks to Wilson College and the convener and the organizing committee of this conference for inviting me to act as a resource person. It is always a privilege to interact with academicians and young students. That is always a refreshing experience and new hope. And when we talk of new hope, I think technically it means sustainability, which is the topic I'm going to cover today. If you look at the title of my talk, I'm talking about two things: sustainable development and mathematical models. Okay. Other talks have been covering the areas of chemistry, zoology, botany, agriculture. I think perhaps a change is introduced here when we are talking about mathematics, and the chairperson of this session said mathematics is not liked by many people. I want to really expel that idea or misconception and want to show that if we are talking about sustainable development, it has to have mathematical basis too. Otherwise, we cannot achieve it. Take it my word. Although the conference is talking about sustainable environment, I presume that sustainable environment is a subset of sustainable development. So I'm talking about the sustainable development more, which we will be covering the sustainable environment. Let us talk of a broader concept. And the broader is also mathematics. The models available are too many to enumerate, but I will start with some elementary mathematical models and also cover advanced topics and relate it to the sustainable development, how we can achieve it and what are the new areas. And I will give examples from Indian applications as well as abroad applications, like that. So let us start our journey. Whenever you talk about sustainable development, perhaps this picture comes in the front, that SDG 17 goals we want to achieve by 2030. And quite a few of them, like number 7, 13, 14, 15, are pertaining to the environmental sustainability. But mind you, sustainability is a property of a global socio-economic system in the context of its physical environment and characterized by complexity. This is very important. See, it is a total system we have to cover when we are talking about sustainability. Akin to, say, temperature, pressure of a gas. We talk it total temperature of a gas or a pressure of a gas. We don't talk about a molecule, a temperature, molecule pressure. In the same way, when we are talking about sustainability, we have to take into consideration overall its expanse, not only just aspect of environment or economics. That's why it's very important to talk about sustainable development and how mathematics is going to support it. That is what I'm going to illustrate. Let us just quickly come to this concept of sustainable development. There are 4 things which can bring about sustainable development. First thing is, we design the human environment according to the given surroundings. If we do that, we can move towards sustainable development. Second is, we do not exceed the capacity available. That is where the problem is. We are exceeding the capacities given by the nature and then talking about the problem. So if we can really work within the capacities, we can move towards sustainable development. Wastes are eliminated maximally. Yesterday we had a session, west to west, something like that. Second session yesterday morning, why to west, like that. So it is same thing like that. Avoid those waste as much as possible. And fourth is, try to see whatever we are doing, the impact of those, effects of those are covered both in space and time adeptly. In that context, this famous quote by Peter Drucker, the management guru, is really very essential. What he said, there is nothing so useless as doing efficiently that we should not be done at all. This is true at individual level as well as community level. Now, what are the determinants of sustainable development? Quickly, I put before you the processes which is causing the problem to our environment. The processes involved are extraction, transport, storage of raw material, production processes, industrial processes, distribution of goods, consumptions of goods, and disposal of waste. These are the basic processes which is causing problem. And let us see in them in the context of some select sectors. Like mining, you know how much problem mining is creating. Agriculture, agricultural waste, we yesterday discussed at length. Forest, their degradation. Energy creation, thermal plant, how much pollution is causing. Water, as we all know, and transport. Now, for both of them, we have got large number of mathematical models. They are, as I'm saying, ranging from simple arithmetic operations to very advanced techniques, like indicators for situation description. The measurement is a key in sustainability. As we had in previous session, nanotechnology, we were measuring something at a very small level. So measurement in terms of mathematics is indicator index. Then cause and effect understanding. Are we taking some processes into action, and that is causing the degradation of air quality? Or we are observing some water pollution and trying to work out what should be their causes. So cause and effect relationships can be beautifully modeled in mathematical terms, like say regression analysis. Prediction. If we continue the same way, what will happen to the air quality? So again, regression analysis, time series analysis, these are the statistical models available. Then equilibrium, we want to have equilibrium between production, consumption, production, waste, and so on. Then control theory, how we can control these processes. Lupno models of control theory are applicable here. And optimization, we want to have best utilization of our resources within given constraints. So there is a full gamut of optimization techniques. Those models can be used. Then network of flows, network analysis, all transportation, water supply, everything is nothing but flows. Even our telecommunication is just flow of messages. So how to optimize this, those flows so that minimum impact is happening on environment. Conflict resolution, there is a conflict at every stage. Within the community, within the nations, everywhere we are finding conflicts. So game theory models and other models are very useful for resolving such conflicts, which are also to be managed for sustainable development. And if nothing of this kind can be modeled, then we have got computer simulation. So I would like to cover all these with certain examples. Within 1 hour, whatever I can do, I will try to do justice to that. Let us spend some time about understanding what is mathematical model. It is a useful practical description of a real world phenomena capable of proving systematic mathematical predictions of selected properties. So the problem could belong to physical world, chemical world, biological, social, economic, or any other setting that can be captured in numbers. Quantification, if it is possible, then mathematical model is definitely possible. Let us come to the operational definition. I am giving references at the bottom of each of my slides, so further details can be obtained. And I think we will be circulating all these PPTs, so you can have it like. Now, operational definition of model is something like this. It is represented by a triplet SQM. S means a system, Q is a question relating with the system, and M is a set of mathematical statements covered under the set of M1, M2, Mn, which can be used to answer the question Q. I will illustrate this later, but understand mathematical model can be represented by these three things, S, Q, M. Now, based on this SQM, we can categorize these models. One is the phenomenological model. Its construction is based on collecting the data. We are not assuming any basic information. We are collecting empirical data and then making predictions. It could be statistical driven or data driven or sometimes called black box model, because we don't know ab initio what is the characteristic of the situation. On other extreme, it is a mechanistics. We have got certain characteristics already available. We just process them and get result. It is called the white box. So mathematical models are divided in these two extremes, which I am showing in this SQM. So at the top, you have got the systems. They could be psychological systems, social systems, economic systems, biological, chemical, electrical circuits. Questions: we want to speculate about certain phenomena, we want to predict some phenomena, we want to analyze, describe certain phenomena, control certain things, design certain things. So these are the questions we want to address. And the mathematical models, as I say, range from black box to white box. So huge amount of tools are available in this spectrum. Further, we can categorize it into non-stationary. If at least one of the system parameters or a state variable depends on time, then it is non-stationary. If it depending on time, it is called stationary otherwise. Similarly, distributed and non-distributed or club or lump, if it is talking about a particular region or talking in the global scale. We can also express this SQM into this three-dimensional model. We can have different kind of tools like analytical, numerical, continuous discrete variable, differential equations, integral equations, and those systems I talked about. Let us apply this SQM to the framework of SDG achievement, the Sustainable Development Goals, like that. So let us take S as a select nation to study its SDG achievement, like India or Ethiopia, something like that. Q is, for example, I'm saying is meeting the state standards. Is that nation meeting the set standard for a particular goal? This is the question we want to address. And mathematical model are covering the statements about S regarding its meeting the set standards with respect to each goal. So this is a phenomenological, non-stationary and distributed model. Distributed because each nation will have different achievement. So it is not related to one thing, it is distributed. It is varying with the time, so non-stationary. And phenomenon, we are trying to define phenomena across the nation, across the time respect. Types of model. It could be linear, non-linear, time dependent, time independent, deterministic, stochastic, dealing with small prototype or complex system, micro level, meso level, macro level, mathematical like ordinary differential equations, Markov chain based, statistical. operation research, or simulation. Broader categories could be something like this: descriptive models and normative models. Under descriptive, we can have only descriptive models like just your statistical graphs. They are describing the phenomena, what is happening, where it is happening, like that. It could be explanatory model, what is happening, why it is happening. Deterministic, can we make future prediction, and probabilistic. Or normative models, means what ought to be done. Understand these two broad categories there, and I will give example of both of them. First, descriptive model. Just this graph. This graph is showing how India's performance is on those 17 goals. This fan is showing, if you say from 0 to 100%, you'll find we have achieved just between 25 to 50% on SDG 2. You see the small fan, whereas on SDG 4, we have crossed 75%. So every year we can have different graphs like this and make a comparison. That is what is the power of mathematics. You can count, enumerate, and compare. And this is exactly required in all our sustainability phenomena examination. Now coming to the normative model. This model is trying to build, say, trunk line for electrical transmission. So what should be the height of the tower and what should be the span of that wire between two towers? And all this should be done within the minimum cost. So mathematically, don't go by that complicated mathematics, but it is showing how we can really build a mathematical model to minimize the cost of transmission. If we want to do that, subject to these technological constraints, then what should be the span between towers, what should be the height of the tower, and what is the wire stress and total cost to be minimized. If we solve this mathematically, this is called geometrical programming problem, you get optimal solution like this. The height of the tower should be 20.40 meters. The wire stress should be 2258, and the span should be 402 meters. And for that cost will be 35,68,000, something like that. So this is the normative model. It is telling me exactly if I do this, I will be achieving my goal of supplying electricity with minimum stress and minimum cost, like that. So we want to have both kind of models if you want to examine the sustainable development. So model development, the steps are: list the assumption, formulate the model, calibrate it, test the data feed, simulate if we are not able to do that, perform sensitivity analysis. This is very important. Whatever results we have got, how far they are sensitive to, if there is a small variation in the data, we'll have to run the model again. How far it is sensitive or robust, that's also important, and update continuously. We can measure the model complexity. It is nothing but minimizing the mean square error, variance, and bias square. It is shown in this graph. Bias square is reducing if we are increasing number of parameters, and variance increases if it is increasing parameters. So the solid curve is showing the combined curve, and its minimum is drawn if we take the x-axis. That is the optimal number of parameters you should use to build the model. So you should not unnecessarily increase the parameters, because it not only increases the complexity, but also increases the intercorrelations, and getting data on so many parameters is also difficult. So what is that optimal number of parameters for model building is also possible to be modeled through a mathematical model given like this. So these are the steps which I already indicated. Just to summarize, mathematical model don't look abstract, it also now based on technology, the computational power given by this. So this is how take it from real world, construct abstractly in mathematical model, try to see can we use computational power of computers, get the results, test them for sensitivity, apply them, If we find there is lacuna, go back, revise the mathematical model with more assumption or generalize and go on like this. So this iterative process can lead you to the answers which will be very useful. There are don't do's of mathematical modeling. Perhaps they are not discussed many times. That's why I'm putting before you. Don't believe that the model is reality. Understand, this is one thing. So there is always a scope to improve your model. Don't extrapolate beyond the region of fit. You have collected the data of 20 years, make prediction only for next 3 to 5 years. Don't predict for next 20 years. Understand? So this is not the way you should use mathematical model. Don't distort reality to fit into your model. I have got a beautiful model, sure, somehow I will fit the data into it. Don't do that. Don't retain a discredited model which has been found out to be not correct. Leave it. Don't fall in love with your model. That is what I'm going to say. Always be open, and that is how math science progresses. We are always open to accept the fallibility, improve, and go further. Now let us come to the application part. Simple arithmetics is required here to know what is the status of sustainability for environment, for economics, or land use. What we do, we collect raw numeric data by surveys or observations like that. We construct table graphs to give the broad ideas. Then we further process that to generate indicators. And then we combine indicators to build one index. So this is the pyramid generally used for building the index to know the reality, to describe the reality. Now, indicator is a direct or indirect measure to represent an attribute like population, geographic region, like that. They can be processed on variety of data you have collected from various sources. It can be a quantitative like mortality ratio, infant mortality rate, and like that, or it could be a qualitative measure also. Then what we do, we combine those indicators to build sub-indices or aggregate them into an index like that. Now let us come to the application. For this SDG, Sustainable Development Goals of United Nations 2030, there are 17 goals we saw in the first slide. There are 169 targets distributed over those goals. And to understand how we are progressing, 230 indicators were identified. Perhaps they have been increased to 232 or 239 recently. Like now, methodology has been given how to build these indicators and SDG index. Simple arithmetic operation is there, but it has been modeled formally. It is quite complex task. Although I am saying simple arithmetic, but it is still a complex task because we have to collect data, consistent data over a long period of time. We have to see that there is no correlation between those data. Like that's why I'm saying reduce the number of parameters. And national properties, geographic properties, their priorities are different to build these indices. And there are methods to build them, track them like that. And they are given by number, a pure number, there is a unit. For instance, Sweden's overall index score is now 86, right? What does that mean? That countries on average 86% of the way to the best possible outcome across the 17 SDGs. Just to show you the latest SDG index for countries, I am showing you the top 10 countries. Finland is 86.8, means out of 100%, they are almost reached 86.8%. Next is Sweden, and so on. These are the top 10 countries on this year. And I'm showing the bottom, where there are 166 countries covered in this index building. And where are we? We are at 112th place. Above us are Bangladesh, South Africa, Bahrain. Below us are Pakistan, Afghanistan, and last is Sudan, 38.7. we were at 115 position in 2019. So we have done some progress and moved to 112. But you can imagine if we want to reach within 50, how far we have to go. So this is how these indicators, the indexes are telling us where are we at and how far we have to go, and then think of how to go. This is the simple arithmetic I said. Z is equal to x minus x min divided by x max minus x min. Means this is the value we have obtained from observations and we build the index Z. Let us not go into detail. And this is how Niti Aayog is following the mathematical model building for India's SDG index. It is collecting raw data across the states. It has set the targets for 2030. Then they have normalized the data, then compute the goal score and composite index. This is all available in this 2000 based report. So Niti Aayog has identified 60 priority indicators. It is consulting the states, and so 38 central ministries and 29 states and 7 union territories are involved in data collection and processing according to guidelines given by Niti Aayog. And it is computing our India score like this, using all these data and this mathematical expression. So understand that although it is just arithmetic operation, but it is to be done systematically. So a sort of mathematical model is used here. Other way of building is what is called the causality network analysis to build the index, sustainable index. It is very complicated model, so I'm not going into detail. But I'm telling you, even to build index, there are variety of mathematical models available. There are lot many research issues even with this research building index. We are assuming all the indicators are having equal importance and combining them. What happens if we vary their weights? And weights can be varied by allocation budgets or using analytical hierarchy process, conjoint analysis, goal programming, data-driven techniques like principal component analysis, data analysis. So lot many issues are there, how to go about building this index. Again, this index vis-a-vis other index available at international level. We have got Human Development Index, Global Happiness Index, Connectivity Index, Peace Index, Terrorism Index. If the Sustainability Index is computed by one methodology and these are computed by other methodology, can we establish connection? If you have higher SDG, do we have higher happiness index? Not necessary. Bhutan is having the happiness index at the highest level, not this Sweden. Like that. So how to really think about incompatibility this index, how we can establish relation with index. This is another research issue. So one can take this as a project. Then can we develop new models to understand the social development and environmental sustainability? How to measure the stability or sensitivity of this index, as I said. How to overcome the problem of data gap. This we face much more in India and developing countries. Data is not available, something like that. And how to define the life quantitatively. This is a still open issue. So many more issues are there. Yeah. The last issue is very important. Develop schemes or models to robust governance in the multi-scale systems. This is the underlying phenomena of sustainable development. How to do that? And the starting point is this: consumption. If we look around the phenomena of sustainability, consumption is the culprit. Our greed, our consumption is really leading to the environmental degradation, land degradation, and so on, like that. So Kenneth Arrow, the Nobel Prize winner in economics, he and his co-workers has come out with this called social welfare function V, depending on time t. So Vt is nothing but summing up of UC, which is the social worth of stream of consumption, discounted at the rate delta. Again, don't get, you can say, dazzled by this integral equation. These are simple economic terms we can express. And the thing is, can we compute this VT for various countries? So what kind of data is required like that? To address the sustainability, how we can maximize the welfare function, this is one issue. But they are saying just don't think about maximization, but see it is not declining. Understand? They are saying we are too much ambitious. We want to maximize welfare, and in that we are degrading the environment. So don't exceed your grid. At least see that for future generation, VT is maintained at the static level, at the present level. So this is one philosophy of building mathematical models to think about sustainable development. Other is called green golden rule. This is also hovering around the crucial phenomena of consumption. Now here it is taking into account past habits. What are our habits of current consumption? Yeah. And what should be the anticipate future consumptions? If we can balance them, we can have green golden rule model. It is a very complicated model. I'm not going into detail, but this says smooth out the consumption, then we can survive. Then there are a lot of mathematical programming models, linear, nonlinear, fractional, goal programming, compromise. So normative models I'm talking about, and how these are applied to the SDG. I'm now taking an example from African countries, right? So in all these SDGs, it can be shown that in first, we want to minimize the poverty. In second, maximize the number of food ratios given to the students. Sixth, maximize kilometer of sewerage line. So we can express each of the goals in terms of these optimization models. So like this. Now I'm just showing the application of linear programming model to achieve the SDG 2, which was basically bringing the food to the African students like that. And the data is like this. If we provide milk, meat, cereals, rice, and fruit, if this is the basket, and it provides energy, proteins, calcium, what should be the maximum proportion given to them with the cost for providing 1 unit of milk and so on. And so total cost is to be minimized and give the maximum energy to the students. So this is how this mathematical model is constructed, x1, x2, x3. And on solving it says, you give 4 portions of milk, 2.5 of meat, 3 of cereal, 1 of rice, 2 pieces of fruit every day to every person. You give the maximum energy at the minimum cost. Understand, this is how the linear programming model is helping to achieve the SDG2 goal in the African environment. Now in real life, there is not only one objective, we have multiple objectives and they can be at conflict. So how to resolve that? That is the multi-objective programming or multi-criteria decision making. And one of the tool is compromise programming. We want to achieve the compromise if we are not able to get the best solution. The idea is something like this. I am giving you 2-dimensional model. We have got, say, you want to purchase a microwave oven, right? You have got 7 models, but we are not able to choose because everyone has certain features. Now let us take 2 criteria. One is durability and other is ease in use. So I am just drawing a graph of x-axis More durability means you move to the right side. More ease in use means move upward. Now, since we are not able to compare them, we construct an ideal microwave. It may not be existing. Ideal means it is maximum durable and maximum ease in use. So that is the ideal shown by the blue star. Now you construct the distance of each of those 7 from that ideal. Simple coordinate geometry formula, right? And whichever is the closest to ideal, that is the best choice. That is the compromise we make. Understand? So this is a simple idea, simple mathematical model. Sometimes we are not able to construct ideal, then we construct anti-ideal. Go to other, right? And again measure the distance. Whichever is the maximum from the anti-ideal, that is the choice. Or there could be 2 or 3 choices. We can use another criteria to break the tie. Now, if we have got many more criteria than 2, we may not be able to visualize, but we can extend the distance formula to higher dimension and break the tie. So this is how we can do like that. More formally, there are tools to address the multi-objective programming models. One is the goal programming model. So in linear programming, you may get infeasible solution, but in goal programming, you will never get infeasible solution because it's characterized like this. It says we want to compute the deviations from all those multiple objectives and we want to minimize that. That is the minimize delta plus and delta minus. And delta plus and delta minus is the deviation variable given for each of the objectives and other constraints. So in the end, we will get that we will achieve the objective 175%, means deviation will be 25%. Or we may get 105% for goal 2. So we may exceed like that. This is how we get the multi-objective problem solved through a goal programming model. And the algorithms are available, computer programs are available. Then a new programming is called nucleosophic programming model. Much more extended version of fuzzy programming model is available and it has been used. Again, I am showing you in the Indian context, Indian case study. 3 SDG goal in the Indian context. We want to increase our GDP growth. We want to minimize the electricity consumption and minimize the greenhouse gas production. So this is how these 3 objectives are listed, Z1, Z2, Z3, subject to constraints varied over 9 sectors of economy. And this is how the mathematical model is. The data is given for all this model. This is all applied in Indian context. And the solution is like this. If we really pursue the current policies, we will be able to achieve GDP goal by 86% of it, electricity consumption goal by 80%, GHG emission goal by 68%. And this will be the employment which will be generated if we are going to achieve these goals and their distribution also. So this is the power of our modeling. New generation of models are coming up. It's called sustainability transitions because we want to move from current situation to new technology based transition. Say petroleum diesel car to now hydrogen emission, hydrogen or biofuel cars like that. So how to model that transition optimally? New models are being generated or are required to be created. Another open issue. As I said, if nothing works, then we have to do the simulation. Simulation can be done what is called Monte Carlo method, where no person involved, but computer is required to generate random variables and give the results. Or agent-based modeling, where human being gives the values at different times, discrete event and system dynamic model. And it basically constructs various scenarios, predictive and explorative or normative. And tools are available, computer programs are available to really operationalize these things. So I'm coming to the last part. So we have got now whole sustainability science, new approaches dealing with complex phenomena, aims to promote solutions which will contribute to the rebuilding the relation proper relationship with human and environment, like that. And again, it requires new mathematical model development. So sustainability science along with new mathematical model-based sciences have to be merged, like location science, imaging science, data science, service science, strategy science. They're all new sciences based on rigorous mathematics. So they are to be combined with sustainability science if we really want to address the sustainability in totality. So I will conclude by saying development without destruction is the essence of sustainability, and mathematical science can help guiding it. Thank you very much.
Thank you so much, sir. Can we now take some of the questions if we have? Any questions from the audience? Oh, there are a couple of hands going. So we first go with the questions by Dr. Jameson Massey. Yes, sir.
First of all, let me thank you, sir, for what a wonderful presentation, especially in the field of mathematical modeling. This is not a question, just, I would like to have your comments when we are in this institute, training graduating students. So what type of model we should use, for a short-term goal achievement, which can, encourage them to move forward for this mathematical modeling, because this is really a future, what I have learned, throughout my research experience. I'm though using, but I would like to have your advice and comments on this, sir.
See, when we are training the students, we are teaching them the basics of mathematics, like that. We are not linking it to the application part. So what I'm saying that you give them small projects. So just for example, we have got huge data of almost every game, Olympic games, Commonwealth games, national games, like that. And some of the games are there for last 100 years in Olympics, like 1500 meters main. Now ask them to collect data of the winners and ask them to predict for next Olympic game, Commonwealth game. And I think 40 students can take 40 different streams of sports, do that.
That's what, yeah.
Yeah, or just ask them to organize a bus route for a school and students coming from different parts of Mumbai. What should be the optimal route for a school bus so that minimum fuel is consumed? There are many such things. Ask them to make a survey standing at the signals and see how much waiting time is there. Can we have vehicle sensitive signaling system? I can give such numerous examples. So make them understand that this mathematics can be used, is useful. Then they can really take interest and get ready for higher order.
And this will also be useful under NEP, wherein we are, teaching the students from other background.
Yeah.
I would also like to know, what softwares you would like to suggest which are available online to, predict these models wherein we can do the simulation.
See, there are variety of models available. The MATLAB is one thing which can be really given the basic training. So they understand how the software works with your matrix operations and so on, like that. Then for linear programming, topo, and there are many. So software are in both categories, open source software as well as the proprietary software. So proprietary are not affordable at the student level. So let them explore some of these open source software. Let them exercise with some fictitious data, then some raw data, and then really the data collection from the field, like that. Let them get hands-on training, because when they go for interview, people will always ask. For pure mathematics also they are asking, do you know any mathematics software? And statistics without software is impossible. So SPS or R, there are many softwares available. Let them master one, they can then any organization will give them training on whatever software they have got, and they can really get familiarized and deliver the thing. So without software is something like running marathon without shoes. So really tell them that you must, even though pure mathematicians, please master one software. That will be very useful.
Is time available? Yeah, sir, it's me. I don't know whether my question is within scope of your research, but Indian monsoon is one of the most unpredictable pattern of the precipitation worldwide, and we are not that satisfactorily doing well with respect to understanding this pattern and even predicting the consequences if the pattern goes this way or that way. What is your personal opinion about this? What are the reasons behind maybe failure or less understanding, and what will be consequences, especially under scene of the global changes and the climate change?
I agree. This is the most challenging topic for research, Indian monsoon prediction. We have come long way in this process also, using supercomputer for that. But still, the number of parameters, there are so many and their interactions are not clear. What will happen if this 1 degree change here will make a huge impact on other parameters? That relationship study is still in infancy. Understand? Although we have identified 17 parameters, what was called Gore model, etc., it was found useful for nearly 1 decade. But of late, it is not found to be useful. What is happening at a macro level, we can make very beautiful predictions. But at micro level, we cannot make it. We can make a prediction for India almost with 95 to 99% accuracy. For Maharashtra, 90% accuracy. For Bombay, 75% accuracy. For Wilson College, 10% accuracy. Because at this micro level, the amount of data collection is very difficult, and the situation is created by variety of parameters. You don't know. Just a traffic jam for 1 hour can change a totally different atmosphere in this region, and rain may go away. That's why it is still all over the world assume that monsoon modeling is still a very difficult thing, and we have to go on improving our models, data collection. See, we had got a very limited data collection points. After the tsunami, we have improved the data collection, but still the number of gauges to be put in it, Bombay itself, they should be in terms of 5,000 plus. We have put only in numbers of hundreds. So unless we get micro level data, we cannot define the model. So up to that degree, our prediction will be not satisfactory.
Sir, there's an online question as well.
Sir,
So definitely as the last question. Dr. Moses, can you please unmute yourself?
Yes,
Dr.
yes,
Moses?
yes, 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 sir. Yes, yes, yes. Sir, I have one question that when we look at sustained development global, that indicator which you have shown, it has been shown for India as a whole. So now, because in India we have different states, so maybe southern Indian state might have been performing well, and if you look for some other maybe western eastern side states, some don't we have such type of state-wise sustainable development indicator, and that will help you to improve the policy and such indicator, is it possible? That was my question.
Yeah, you are very right. For positive time, I did not show you each state indicator. Each state's indicator data is available. It is shown in the report every year, and for the right since 2019 till 2023, Kerala is state number 1. Understand?
Yes.
We are rightly said southern states are in forefront in achieving those SDG goals. So the data and results are available, and if you take the Niti Aayog report, you will get for each state and where they are lagging and what should be done. All that discussion is there. So all that is aggregated into India Index. For positive time, I did not go into it. I can show you India map is there, where each state is, how far it is lagging, etc. All those details are available. If you want, you just use go to the Niti Aayog website and get it, or otherwise I
Yeah,
will also supply you.
yes, sir. Just one, sir. So now, since you have shown that we have very low index as Indian, as in India across global. So now, majority we focus on maybe urban means our development programs. Majority we are focusing on cities. So how we can improve means I want to say that our policy must be focus on rural region and then develop that, and how we can improve that index in that.
No, we have to work on both the fronts. See, cities are the engines of growth. That is one thing, because you see the GDP, etc., the more than 50% contribution came from Indian cities. But at the same
Yes.
time, if we can provide these kind of facilities
Yes.
in the rural areas, that is the concept
Yes.
given by Abdul Kalam, or what is called sillage,
Okay.
city-like developments of villages. The Anil
Yes.
Kakodkar has been propagating that phenomena. If we can take it to logical end, then we can really improve our position and at least come within first 75 countries. Not
Yes, sir. Yes. It was nice talk. Thank you. Thank you, sir.
Due to paucity of time, we are unable to take more questions. But I think this was one of the session where we had so many questions being asked. So, on behalf of the management, the principal, the teachers, the participants, I'm short of words actually to thank you enough for making such an impactful session on our theme of sustainable development and how mathematics can influence. You have gone through a very simple but a very detailed presentation talking about sustainable mathematics in sustainable development vis-a-vis sustainable environment. You've gone into details of talking about the four bases for sustainable development, the determinants, the processes, and you have very articulately and in a simple way discussed different types of mathematical models and how they can be used to study the issues pertaining to sustainable development and to achieve the 17 targets given by the United Nations, the goals to achieve them. Sir, with your simple, lucid, yet very effective presentation, you have amply justified with enough examples and case studies and proved that it is impossible to think about achieving the sustainable development goals without mathematics. We sincerely hope that this session of the conference has removed the fear of this great subject, mathematics, and I am sure the participants will agree, B, emphasized on the impact of mathematics on our lives, C, role of mathematics in sustainable development processes for sustainable environment and sustainable development. You have also introduced to us sustainable science with the role of mathematics, a pivotal role. You have given so many different models, but I just remember one statement from your model, and that is don't fall in love with your model. To conclude, I just want to say we just can't but fall in love with your lecture that you have given to us. A round of applause to Dr. Patkar sir, and a takeaway in this session for the teachers specifically, you are a model of how to be an effective and a teacher who can make an impact of the subject on life. Thank you so much. We are so privileged to have you today with us. Thank you so much.
Thank you, Dr. Vivek Patkar, sir, for educating us with the role of mathematics in achieving the sustainable goals. I would also like to thank Dr. Ashish, sir, for chairing the session. We will take 5-minute break. During this break, all the participants are requested to fill up the feedback form for this session. Link for the same is already posted in the group. Thank you. Hope everyone is back in their seat. We are beginning our third technical session. We are proud to have with us Dr. Narsingh Thakur sir, Senior Principal Scientist and Head, Chemical Oceanography Division, ACSIR, School of Oceanography. He will be talking on sustainable utilization of marine resources. This session will be chaired by Dr. Jamson Masih, Assistant Professor, Department of Chemistry, Wilson College. Dr. Jamson Masih has published 30 research papers in reputed journals. Also, he is recognized with many research awards and fellowships. I request Dr. Jamson Masih to introduce our speaker and chair the session.
Thank you, Dr. Pooja. And good morning once again. Welcome to this technical session 3 of Interdisciplinary National Conference on Scientific Approaches for Sustainable Environment. I am Dr. Jamson Masih, Associate Professor, Chemistry Department, and I will be chairing this session. And the session will run from 11:30 to 12:30, though we are running a little late. And before we proceed further, let me take this opportunity to introduce our speaker for this session. Friends, we have this morning with us Dr. Narsingh Thakur, who is born and brought up in beautiful coastal village Mahapan of Sindhudurg district, Maharashtra. After completing his graduation and post-graduation from Mumbai University, he started his research career at CSIR National Institute of Oceanography, Goa, as a research fellow on an Indo-US project on marine borers by availing CSIR research fellowship. He has completed his PhD research at CSIR NIO in the field of marine chemical ecology and biospectring. And the degree was awarded by Goa University. During his PhD, he was selected for Indo-German Scientific Exchange Program of DAAD, Germany, which is one of the world's largest funding organization. He was a postdoctoral researcher at University of Mainz, Germany during 2001 to 2005, where he was involved in marine sponge genome project under Biotech Marine Consortium. Before joining CSIR NIO in 2007, he had established and led Marine Biotechnology Group at Nicholas Primal Research Center, Mumbai, to discover marine-derived bioactive molecules for therapeutic applications. Presently, Dr. Thakur is a senior principal scientist at CSIR National Institute of Oceanography, Goa, and heading Chemical Oceanography Division. He is known for his research work on marine chemical ecology to understand chemical interactions between marine organisms at different trophic levels and translate this knowledge for bioprocess spectring. Ladies and gentlemen, let us welcome Dr. Thakur, who has more than 20 years of research experience in the field of marine biology and biotechnology and has 45 research publications to his credit. Dr. Thakur, we extend a hearty welcome to you to accept our invitation, and over to you, sir. Thank you so much.
Yes, thank you so much for this introduction. I'm sorry, actually, I'm joining this meeting from Delhi where Global Bio Summit is going on. That is a DBT summit. And somehow I have to manage to join this meeting and give my presentation. Am I audible? Hello, can you hear me?
Yes, sir, we can hear you.
Yes. Okay, so I'll share my presentation. Is my presentation visible?
Yes, sir, it is visible, sir. You can start.
Okay. Okay,
Sir, can you put it on the
title
slide
of my
mode?
presentation. Yeah, I'm just searching for that. Yeah,
In
now it is
slide
fine.
shoulder on the top.
Is it okay?
Yes, sir, fine.
Okay. Yes. So, title of my presentation is Sustainable Utilization of Marine Living Resources. And as just now, sir has introduced, I am from National Institute of Oceanography, Goa. Okay, so when we talk about sustainable utilization of marine living resources, then we have to understand what are marine living resources, why marine living resources are important, and how can we protect these marine living resources for mankind. So this is a first slide where you can see a zonation of the sea and creatures, marine creatures living at different depths. Where this part, which is intertidal region, which is covered during high tide and exposed during low tide, is very much important as far as the marine biodiversity is concerned. That is the intertidal region, and then subtidal region up to 200-meter depth. So this is a photic zone, and you can see a lot of organisms are settled or live.
Sir, can you hear us?
Part where the organisms are living at the bottom or attached to the substratum. And here the sunlight can reach up to 200-meter depth. So this is the photic zone. A lot of photosynthesis is happening through microalgae and macroalgae in this region. And this is supported, this particular ecosystem is very much rich and a lot of creatures you can see in this ecosystem. Then you have different depths of the ocean, and up to 10,000-meter depth also you can find life. Of course, these organisms are adapted themselves for those conditions. Apart from intertidal and the subtidal region, we also work at this depth, that is a 1,000-meter depth, where we have a lot of methane seeps, coal seeps areas, and a lot of unique organisms we can find here. So this is basically about the marine living resources. So marine living resources include all the living organisms, right from microbes, algae, seagrass, mangroves, and animals in the marine environment, not only in the ocean, but also including the estuaries. The organism which you find in estuaries also comes under marine living resources. So few more slides I will be sharing about marine living resources. This is my favorite animal, that is a sponge. Sponge is coming under Porifera, first phylum of the animal kingdom, everybody knows. And you can find almost 9,000 species of the sponges all over the world. Out of that, 450 sponges are present or recorded from India. Then corals, algae, zebra mussels, bryozoans, barnacles, jellyfish, these are different animals included in marine living resources. Then echinoderms, very much important from economic point of view, these organisms. Then question is why we have to study these marine living resources. The marine living resources, there is a connection of blue economy. These days we are hearing a lot about the blue economy. Blue economy is that, what is that, sustainably using marine resources, not only living resources, but also non-living resources for the benefit of humankind. That is a blue economy. And in marine living resources, so actually a very important functions. There are ecological functions that providing coastal protection. Also, these resources are useful for food, energy, biotechnology products, and also supporting tourism and economic development. So you can find that ecological functions in this particular picture. Then bioenergy, I have just selected few of these where we can connect the marine living resources with blue economy. And then healthcare product, which I will be talking about in more details. So how we use marine living resources to ensure population of these vital stocks remain at the harvestable level, that is a sustainable utilization of marine living resources. So far we have seen that there are a lot of organisms, including microbes, macroorganisms, algae, plants, and there is a utilization or importance of these organisms for human being. But the question is that how we can use these organisms in a sustainable way so that there is an economic benefit as well as we are protecting or conserving or maintaining the ecosystem. So that is nothing but the sustainable utilization of these marine living resources. So under Sustainable Development Goal 14, that is a life below water, these are the features which are important for sustainable utilization of marine living resources. So first one is prevent and reduce any kind of marine pollution. Maybe it is a coastal pollution, oil pollution, or microplastic pollution, which is very hot topic these days. Then minimizing the ocean acidification. You know that acidification is increasing, and due to that, many organisms are suffering from the acidification. Then effective regulations of harvesting and stopping overfishing, unregulated, unprotected, and illegal fishing, and also not only fishing but also harvesting other marine living resources which are not coming in fisheries, and there should be a proper or effective regulation. Then conserve at least 10% of marine and coastal areas in agreement with international and national laws. You know that there are a lot of oppose or the protests from the local communities, but we have to convince them that properly how this conservation of certain areas for the marine or coastal areas are important. Then improve research capacity, that is scientific knowledge, and share the technologies or utilize the advanced technologies, not only for the conservation or the protection or sustainable utilization, but also for, say, exploring these resources for economic purpose. Then ensure easy access to small scale fishers to market and marine resources. And finally, increase the financial benefit to the developed and developing nations. So which includes all these things, management practices of aquaculture, tourism, fisheries, everything. So now, as I told you before, I'll be focusing little bit about the how these marine living resources can be used for various bioprospecting purpose, like various biotechnological application. And the one area only I have selected here, that is the therapeutic molecules from these marine living resources. So in my further few slides, I'll be just talking about how these organisms are important for us for therapeutic applications or developing any molecule for therapeutic applications, and how can we use these organisms for this purpose in a sustainable way. So without risking the species or without over harvesting the organisms from the nature, how we can serve the purpose. So first of all, the question is that you can see the picture. In this picture, there are sponges, different sponges. Also, there are zoanthus. And here is the molecule. This is a candidate molecule I have selected for this. The question is, why do these organisms secrete molecules? Okay, because I just talked about that there are marine living resources, and these marine living resources we can utilize or use for therapeutic applications or to develop drugs or the molecules for therapeutic application. So where is the connection? The organism which is sitting, suppose, in the Juhu Beach or any coastal area of Maharashtra, Goa, anywhere in West Coast, and the drug development, where is the connection? So in my next slide, you can see that there is a chemical ecology involved in this. So a few examples, like there is where these organisms are living, there is an extensive ecological pressures, like there is a competition for space, there is a predation pressure, there is associated fauna, and the poor organism, like this is the case of the sponge I'm just talking about. The sponge is soft-bodied, sessile, means stick to the substratums. Sponge cannot move from one substratum to other substratum, so it is a arriving different means of physical defense, but sponges are not having, a sponge is a candidate organism. Many organisms in this category are not having okay, physical defense. So you can see the space competition, very limited space, and many organisms are trying to settle on that space. They're struggling for the settlement, and if the free space is not available, then one organism is growing on other organism. This is some sort of fouling or epibiosis you can call. You can see that here is a zooanthus, sponge, algae is a severe competition. Then you can see the predation. There are fish and any other animals are ready to attack the soft-bodied animals or graze over it. You can see this gastropod is grazing over the sponge, or the fish is biting sponge. So there is a predation pressure. And also there are associated organisms which can trouble these big or the macro organisms. Like you can see in the sponge. Sponge is a filter feeding organism. So sponge is taking a lot of water, and through the water, a lot of pathogens and other microbes are entering. So sponge is almost having 40% biomass of bacteria in it. So you can imagine how much pressure is sponge is bearing. Then sponge is having a lot of pores because there is a water circulation system. There are osculums and ostia. So many animals like these brittle stars are living in the sponge, providing shelter for different animals. So again, there is a pressure of associated fauna. So now the question is, how does this simple sea creature survive in the competition? There is a competition for the space. There is a threat from the predators. Then there is a problem of the associated animals and these chemicals weapons. Actually, these organisms living in the ocean, they use these chemicals for two different reasons. One is that communication. These are infochemicals. They communicate with each other by using chemicals. Those are infochemicals. And they use chemicals for their defense. Those are allelochemicals. So all these chemicals of different classes are allelochemicals. And these are chemical weapons for these organisms. So this is a simple slide where you can see there is a link between this chemical warfare going on in the ocean and human health. So here is the sponge. Sponge is filtering a lot of water, and through this filter feeding, a lot of pathogens are entering, as I just now mentioned. And to kill these pathogens or to get rid of these pathogens, sponge is secreting antibiotics. Possibly we can use this and
Sir, can you hear us?
similarly, there are cytotoxic compounds produced by the sponge to control or rapidly growing cells of their neighbors. Otherwise, there is a fouling problem. So for this space competition, they use a lot of cytotoxic molecules, and definitely these cytotoxic molecules are useful for cancer chemotherapy. So drug discovery from natural sources, whether it is terrestrial natural products or marine natural products, it is a very complicated process of the program. I would say maybe 10 to 15 years or more than that years are required. And interdisciplinary work where you are starting from marine animals, the involvement of marine biologists, ecologists, then you are identifying the molecules, again, natural product chemists, then a lot of in vitro, in vivo assays, and then you are going for chemical synthesis, then toxicity testing, then pharmacokinetics, pharmacodynamics, formulation people are involved, clinical people are involved, and finally you have drug, the molecule is reaching to the market. So this is very much complicated process. But there are successful stories you can see. And if you compare the drug discovery from terrestrial natural products and marine natural products, definitely the success rate is more in marine natural products. Also, this area is completely unexplored. Very few companies or institutes are working in this area, but you can see these are the molecules derived from the sponges, and which are at different stages of development. Some are in market, some are in phase 2 clinical trials, some are in phase 1 clinical trial, and you can see the companies all over the world involved in developing these molecules from marine sponges. So now you would see that there are almost 25,000 plus molecules are discovered from the nature, especially from marine system, but hardly maybe 15, 20 molecules are in clinical trials and 5 to 10 molecules are in markets. So what is the problem? Where is the bottleneck? So here is a bottleneck, the lack of sufficient material. In fact, the major limiting factor for the development of marine derived compounds for any drug development purpose or the commercial applications. So I would give you an example of one sponge, that is sponge Losodendrorix, this sponge is producing one anti-cancer molecule that is halichondrine, and requirement of halichondrine just for completing clinical trials. These are preclinical and clinical trials, is a 5 kg per year. And for this, to get the 5 kg molecule, you have to harvest 16,000 metric ton of the sponge. So now, just think, is it possible to get this much material from the nature? By if you are doing that, then there is a risk of extinction of the respective source species. So this is a bottleneck. You cannot get the biomaterial or the sufficient amount of the material for any commercial application of these organisms. So what are the solutions, possible solutions for this? First one is mariculture. People are trying to grow these sponges in controlled, sponge means sponge or any other organism, which are commercially important in controlled condition, like how we do aquaculture. Similarly, that is a mariculture. But as I told you before during my chemical ecology discussion, that these organisms secrete molecules for their own purpose, like for the defense. And if they have a secure environment where they don't find any enemy or any reason to secrete these molecules, they definitely do not go for secretion of the molecule. So this approach is not very much successful. Then people are trying for cell culture. You can in controlled condition in the laboratory, you can grow the cells. Of course, there are again different issues related to cell culture. That much biomass is not possible from the cell culture. Also, there is a problem of bacterial contaminations, fungal contamination. Then third one is a molecular biology. A lot of biologists are attending this webinar, and in our colleges and university, we hear a lot about the molecular biology and recombinant DNA technology, and which is very good, very nice to read and then understand this concept, but definitely difficult when we actually take this in practical, especially in the case of marine natural product drug discovery, because these molecules are not secreted by a single gene, which you can take it from your source organism and put it in E. coli, and E. coli will start producing molecules. This is not so easy way of producing these molecules, but there is a gene cluster. There are a lot of 7 to 8 different genes are involved in the production of these molecules. So there is a gene cluster, and that's why this is a complicated process, and very hardly 1 or 2 examples, successful examples are there. So only way presently is to get these molecules is a synthetic chemistry. You can, once you know the structure, because nature is just giving us a structure. So once you understand or know the structure, this structure of the molecule, and this molecule is useful for this particular purpose, then you don't have to go and harvest the source species in large quantity and destroy the nature. Once you know the molecule, you just go ahead with synthesis of the molecule in the laboratory. You can see here a picture of marine living resources and our coastal areas. India is having total coastline of 7,516 kilometers. There were mainland coastline, then islands are there. And this is our exclusive economic zone. And almost 14.2% of our population is living in coastal areas. And for this population, whether it is fishery or any other animals, any marine living resource, you want this for the purpose of sustaining or for the use of this population from not only from the coastal, from other parts also, then you have to use these organisms in sustainability. So what are the efforts under the life goal 14, that is a sustainable development goal 14, that is life below water. That is a conservation and sustainable use of ocean, seas, and marine resources for sustainable development. So here I'm just giving you overview of our parent organization, that is CSR, Council of Scientific and Industrial Research, which is having 38 different laboratories, and CSR NIO is one of them. So these are the plans and action plans and R&D projects presently going on in CSR Institute. Almost 7 to 8 CSR institutes are involved in different projects. Of course, the CSR NIO is the major institute where reduce marine pollution. There are projects on microplastic pollutions and metal pollutions, oil pollutions, then restore ecosystem. restoring coral reefs and developing artificial coral reefs. We are working for our regional center in Mumbai is working on restoration of coral reefs. In Mumbai also we have done the project on this aspect. Then reduce ocean acidification. We are the projects running in this. Then sustainable fishing, where you can find the prediction of potential fishing zones on your mobile, the fisherman's mobile. You get the message that so and so latitude, longitude area is a potential fishing zone today. Then they can go there and do fishing. So this is also one of the ways to control the what is the fishing and in a sustainable manner. Then conserve coastal and marine areas and increase scientific knowledge for research and technology for ocean health. So in this sustainable exploration of marine living resources for bioprospecting purpose, we are having different ways where we use these marine animals or the organisms in sustainable way for application or the biotechnological application. So marine bioprospecting theme where CSR, NIO and my particular group is working, where we are exploring molecules for therapeutic applications, functional foods and supplements, natural pigments, hydrocolloids, and microbial enzymes. And these are our marine living resources, including marine invertebrates, cold seeps and deep sea biota. Biota. So cold seep means the area where the methane is coming out from the sea floor, and this we have identified in India, in the east coast of India. Two cold seeps areas, and I was recently discovered in last 5 years, where you can see that the organisms are chemosynthetic. They are not using photosynthesis for their nutrition, but the chemosynthesis, where they are taking methane, sulfur, and then use that as an energy. So this is very interesting ecosystem, and we are exploring this ecosystem not only for bioprospecting, but also for the biodiversity purpose. Then microalgae and macroalgae we are utilizing for this purpose. Then microbes associated with organisms, including the deep sea microbes, and then extremophiles, like as I just now mentioned, cold seeps areas or hydrothermal areas where a lot of animals which are surviving under extreme conditions. So these animals we are using for the purpose, like you can see the cell culture. Of course, the cell culture approach we follow in the lab, but it is not for commercial purpose, but to understand the biology of the marine animals, we use the cell culture. Then mass culture of animals in closed condition we do. This is the amphipoid species which we are growing, and this amphipoid we are using as a live feed for the fish and shrimps. Then also we have developed what is a sustainable way of culturing or utilizing the seahorses. Seahorses are having a lot of medical applications, but this is endangered species, controlled or the restricted for collection from the nature. But where we are producing these seahorses in the laboratories, and then we have completed their life cycle, and in a sustainable way, we are further exploring these organisms for various applications. Then the microbes. Actually, as far as the marine bioprospecting is concerned, if you are trying to explore these organisms like special invertebrates for any application, it is a bit difficult, but because the source issue is there. But if it is a microbe, then you can use these microbes for various applications, right, from drug molecules, pigments, biopolymers, cosmetics, and where our job is easy because we are using fermentation technology. Once you have a culture of your microbe, then you can go for fermentation technology and extract your molecule in large quantity. So by using this fermentation technology, this is also a sustainable sustainable way of using marine microbes for application purpose. So you can see culturing of deep sea microbe we are doing, that genomics and proteomics studies are there. Fermentation technology for various things, like not only for the drugs or the small molecules, but for the proteins and then pigments. We use this way for exploring the microbial applications, especially industrial applications of microbes. Then marine microalgae. These microalgae, the source is sediments, seawater associated with plants, animals. And these are the applications of microalgae. And we are growing this microalgae in photobioreactors or small open ponds where once we have a culture and then we can grow this culture in large quantity in a sustainable way. Also, macroalgae, there are a lot of projects going on in CSR, our parent organization, including CSMCRI, also in NIO. And there are different applications of macroalgae. Everybody knows about the application. And then for this seaweed research. So different 3 types of seaweeds are there: green, brown, and red, where the cultivation is being carried out in open ocean or in the coastal areas of, say, Tamil Nadu. And now NIO and CSMCRI is exploring more possibility along the Goa and Maharashtra coast or the west coast of India for growing seaweeds, the local species, so that there is no invasive species coming from different region to our region, but the local species, how we can grow, which can support the coastal people financially. And also we can explore these resource in a sustainable way for economic development. So this is all about the technical things about what are marine living resources and what is the importance of marine living resources, and finally how we can use these marine living resources in a sustainable way. So now a few slides about our institute, because I guess is the headquarters, and we have 3 regional centers. One is located in Mumbai, one is in Cochin, and other one is in Visakhapatnam. So we have 2 research vessels, and these 2 research vessels, because the oceanography or the marine biology, you cannot study only by sitting in the lab. You have to go to the field, and not only intertidal or subtidal region where we can collect the samples or analyze the samples or explore these marine living resources by visiting the place or by diving, but you have to go to the ocean, open ocean, and for that purpose, these 2 research vessels are well equipped on board laboratories of biology, chemistry, physics, and then can go up to, say, 5 kilometer or 6 kilometer depth and get the samples. So all these both the research vessels are well equipped with sampling equipments and laboratories on board. And also we have a strong group of marine biotechnologists. I'm just talking about marine biotechnologists, not included marine biologists here, because we have to understand the marine organisms, their ecology and their habitat, and how we can use these marine living resources for economic development or blue economic purpose or biotechnology purpose in a sustainable way. So marine bioprospecting is a group which is taking care of the first part, and then the translational research part also. So group of 25 scientists, and you can see different things are mentioned over here. And we have a repository of, say, more than 1,000 metabolites, which are isolated from the marine living resources. And this library is available for screening of these molecules for any further applications in any biotechnology areas. And this is especially for the students. We are running PhD programs. One is under Academy of Scientific and Innovative Research. I'm coordinating this CSR activity, this PhD registration, biological sciences, chemical sciences, physical sciences, and engineering. We are admitting a student. This was for the August semester. Every August we admit, but now we are starting a January session also. So twice in a year, we are admitting students who are, especially students who are having their own fellowships, any national fellowship. And then one more program we are running, that is a doctoral research program, where you can submit your application throughout the year, and then you have to register under any university where NIO faculty is recognized. Also, apart from PhD program, we are taking a lot of students for dissertations and internships, right from 1 month to 1 year at NIO headquarters, as well as our regional centers. You can check our website for more details. So that is about our marine living resources, sustainable way of utilizing marine living resources. I have kept my presentation limited because I would like to interact more with the participants. If you have any specific question, we can take and we can discuss in this session. Thank you very much for your attention.
Thank you, sir, once again for such an elaborated talk on the marine biology. And before we propose the formal vote of thanks, I would like to encourage our participants to have few questions, as sir would like to have an interaction with you all. Sir, we have a question from one of our professors from zoology department.
Good afternoon, sir. My question is, till now, what is the findings of these micromolecules from Indian coast, which are being used in medicines, or I would say the molecules which have been extracted from Indian invertebrates are in medicine form?
Could you please speak a bit loudly because, or you can repeat the question otherwise, sir.
I just want, is there any medicine in Indian market which has been made out of?
Yeah, I understood. Yeah, I got it. You mean, is there any success story or any medicine discovered from marine sources of Indian coast, right? That is your question?
Yes, sir.
Okay. Yes, very interesting question. So far from Indian coast, as far as therapeutic application is concerned, as a drug molecule, there is no a single molecule entered in clinical trial yet. But there are many success stories where we have reached up to, we have completed preclinical studies, and very soon the molecule will enter in clinical trial. For example, our group has developed one antibiotic in collaboration with Nicholas Piramal earlier, but now NIO is taking up that molecule, and very soon we are filing investigational new drug application. That is IND filing, very important step where we have completed all preclinical trials, and this molecule is specially for hospital acquired infections, say for MRSA or VRE infections, and hopefully this molecule will enter in clinical trial. Of course, as I mentioned, drug development or developing molecules for therapeutic applications, very complicated process. It takes a lot of time, lot of investment or funding, but we are progressing in that direction. Very soon we can see few molecules from Indian marine living resources for therapeutic applications.
And my second question is, do we have developed any method for culturing these invertebrates so that we can give these methods or what do you call it, a way of culturing these animals?
Any method for what you said?
Sorry, sir?
Sir, please repeat his question. What is asking?
My question is, do we have developed the method how to culture these invertebrates so that the fisher folks or the interested people will come together and they'll start culturing these organisms in aquatic environment so that we get the molecules for medicine purpose?
So you mean whether we have developed any process of culturing these animals?
Yeah, culturing these invertebrates.
Culturing these animals. Yeah. Invertebrate culturing, only seahorse we have developed a procedure or the method or the protocol or the process. But not for the sponges and all, because I told you the problem. These sponges or any invertebrate in this category, if you try to culture them in closed condition, they don't secrete molecule. Okay, that is a problem. But seahorse, of course, we have developed a process of technology, and it is available for any fishermen or anybody who would like to use it. Then, but for seaweed, yes, seaweed, the protocol is already established. Our institute as well as CSMCRI is doing this practice of culturing seaweed. The technologies or this know-how is transferred to the self-help groups or the local fishermen for culturing seaweeds.
Okay. Thank you, sir.
Yes, thank you.
Thank you, Dr. Mane. Sir, there are few, questions on the chat box, and participants are also acknowledging your talk. So let me just read few questions, sir, for you. Thank you, sir, for the session. What potential biomaterials can be produced from algae or other marine organisms? This is the first question which has come on the chat box, sir.
You mean biomaterial is asked?
Yeah, biomaterials can be produced from algae
Yes.
or other marine organisms.
Yeah, definitely. Biomaterial is very interesting area as far as the marine living resources are concerned. And you can see this biomaterial, marine derived biomaterial can be used for various applications, including say in dental application or in bone or in skin related applications. There are a couple of things which are in the process of development. One is the collagen. So we have developed this technology to extract collagen from jellyfish. Otherwise, you can see that there is a bloom of jellyfish in particular area, a particular season, especially after monsoon, that is a post-monsoon time. And these jellyfish are really creating havoc and then very injurious or danger to the tourist, and it is of no use. But this biomass we are harvesting for extracting the collagen, type 2 collagen, and this is useful for developing the wound dressings for burn and other wound related issues. So that is one biomaterial we are developing. Also, we are working on biosilica from microalgae and biosilica from the sponges kind of animals. And this silica is useful, say, for dental or bone regeneration purpose. So there are a few examples of developing biomaterials, and of course these the area of research is developing interest, and many scientists or students are working in this area, that is marine derived biomaterials. Yeah.
Thank you, sir, once again for answering the question for Dr. Tyagi. And there is one more question which is application oriented and very interesting. That is, sir, even microalgae has application in bioplastics. So how one can come with a startup? Should the funding in this area be increased?
Yes. See, no, microalgae definitely is having a lot of applications, as you have mentioned one, but you can extract a lot of pigments from the microalgae, and there are so many startups which are coming up in this area. Actually, interestingly, I'm in the hall where I'm sitting in Delhi in Bharat Mandapam, where this exhibition is going on. That is a DBT BIRAG exhibition. Almost more than 500 stalls are and startups are participating in this, and they are showcasing a lot of opportunities, especially for students as well as faculty members to go for a startup. And you can, this particular thing, you can check website of BIRAC, BIRAC. They have many schemes where they support your idea, even the proof of concept level proposal, to go ahead for supporting the startups. Okay, but you can take my contact from the organizer and you can interact. I'll definitely provide you more information in this line.
Thank you again, sir. There is a question to have your guidance to some of our colleagues or students, and they want to know, sir, if we want to collect samples of bioluminescence microbe, what should be the level of water in oceans?
What should be the bioluminescent
level of water in ocean. So this is for collection of the sample, sir.
I'm sorry, sir, I will not be able to answer this question.
No problem. Thank you, sir.
I don't have any idea about this.
Who has asked this question, they can get in touch with you, sir, and if you could help them. So thank you once again, sir. We will, I think, restrict here. Otherwise, there will be many more questions. We are sorry you wanted to have interaction, but we will have to stop here because of the time, sir. So, sir, we thank you to enlightening us and a participant with the biological components of our ocean, which includes anything from fish, microbes, and animals to massive fish. And I'm 100% sure that our participants are benefited to know, as you have elaborated your talk, that use of these resources to produce food, feed, bio-based goods, and bioenergy, as they are very essential to human existence and are highly valuable on an ecological, social, and economic level. And finally, your presentation is an eye-opener to showcase the diverse application of marine life resources and offer suggestions for their sustainable use. We are so grateful for your time and efforts in speaking at our event. Your words were inspiring and your presence was invaluable. Thank you for taking the time to be with us. Thank you so much for this talk, sir.
Yes, thank you, sir. Namaste. Thank you.
Thank you, Dr. Narsingh Thakur, sir, for sharing your work with us. I would also like to thank Dr. Jamson, sir, for chairing this session. I request all the participants to be in the meeting because we are starting with the next, that is last technical session. To deliver this technical session, present among us, Dr. Anil Gore, Assistant Professor, Department of Chemistry, Tarsadia Institute of Chemical Sciences, Gujarat. Sir will be talking on sustainable hydrogel for water waste treatment, a circular economy and zero waste approach. Dr. Harish Chandra Parbat, Head, Department of Chemistry, Wilson College, will chair the session. Dr. Parbat has 23 research papers to his credit. Also, he has recently got Asian Achiever Award by international body. I would like to call Dr. Parbat sir for introducing today's speaker and chairing the session.
Good afternoon to everyone. This is the fourth technical session and last of this day. As well as this is the before lunch break for the everyone. That's why this is a very important session for the participants. It is my pleasure to introduce today's fourth technical session resource person, Dr. Anil H. Gore. Firstly, I will welcome Dr. Kiran Gore on behalf of Wilson College Management, Principal, Conference Convener, and Organizing Committee members. Dr. Anil Gore, sir, has completed MSc in Analytical Chemistry from Shivaji University, Kolhapur, as well as PhD in Analytical Chemistry from Shivaji University, Kolhapur, under the guidance of Professor G.B. Kodekar, sir, in 2013. Dr. Anil Gore is an eminent academic and analytical chemist with a rich background in academia, research, and industry. Currently working as an assistant professor in analytical chemistry at the Tarsadia Institute of Chemical Science, Surat. Dr. Gore has made significant contribution to the field of analytical chemistry, particularly in the domain of sustainable nanotechnology. Currently, Dr. Gore is guided 4 PhD students and 40 plus MSc research students. He has more than 75 research papers, 3 patents, 6 book chapters, and 6 reviews to his credit. His work has significant recognition, evidenced by an impressive citation count of 1,823 and H index of 24. Dr. Gore has actively participated in conferences and seminars, presenting posters and delivering the talk at national and international this award from DST Sub in October 2016 and being recognized in the World Scientist Ranking by AD Scientific Index from 2021 to 2024. Last three years, 2021, 22, 22, 23, and 23, 24, 3 consecutive years, he's got the top 2% World Scientist Ranking. Dr. Gore is also an expert panelist of the Emerging Issues Working Group and member of AOAC Southeast Asia. Dr. Gore's research interests like in analytical chemistry and sustainable nanotechnology. His focus areas include the development of carbonaceous materials and biopolymeric hybrids for the removal and analysis of emerging pollutants. In addition to his academic and research pursues, Dr. Anil Gore actively engages in additional editorial responsibilities and has been associated with reputed journal as an associate editor and reviewer for ACS, RSC, Elsewhere, and Springer. Sir will talk on the today's topic, that is sustainable hydrogel for water, wastewater treatment, a circular economy and zero waste approach. Sir has the very lengthy biodata. We are reducing according to convenient time. I think I will call to the sirs to the next session. That is Dr. Gore, sir, over to you.
Okay, thank you, sir. Thank you for nice introduction. I'm audible?
Yes, sir, you are audible.
Yes, sir. Yes.
You are the co-host. You can share the screen.
Okay, thank you, sir.
Yes, you.
My screen is visible, I hope.
Yes. You can go ahead.
So, good afternoon to one and all the organizers and all the team members of the Wilson College. Already, sir has given the detailed introduction about me. And let us start with the not wasting any time. Start with our today's topic is the sustainable hydrogels for the water or wastewater treatment application via circular economy and zero waste approach. So let us see. My talk is I will start. This is just for example. We can say this is for information. Nowadays we are one by one, day by day there is a depletion of water sources, and as we know that we should know what are the water distribution on this earth planet. So water distribution on this earth planet is about, we can see here this sorry, only we have the 0.3% of the surface water, and all these water are made use for the as a surface water for different applications like industrial use, domestic use, and so on. So here these water sources, either surface water sources are there or groundwater sources, underground water sources are there. So these are getting polluted day by day because of different anthropogenic activities on this planet. And as you know that we are in the 21st century and we are developing all the things, aspects of the chemistry and sub-engineering aspect. So most of the industries like pesticide industry and some other related industries, stakeholder to chemistry and other related areas are discharging lots of chemicals and other related pollutants in water. And no doubt there should be or there will be they are doing some treatment of water, but these treatment technologies are not that is up to the mark to get the free to get the rivers and surface water free from the pollutant. So let us see, these are the sources. So our as per the water distribution, main water sources are available are the groundwater sources and surface water sources. So these water sources are polluted by different means, that is groundwater by landfills, uncontrolled hazardous waste, atmospheric contaminants, storage tank, etc. And surface water pollution is about the oil spillage, agriculture pesticides, radioactive river and marine dumping, and so on. So all these are making very critical issues because of different stakeholders discharging the water, wastewater or pollutant in the water, and water get polluted. So here we have to we have to change our view about the thinking what actually we have to do for that. So here we can we need to change the perception about about wastewater. It is a very big resource, as worldwide there is it is wastewater, but it should be the water, it should be the pure water. So here we have to need to change the how to waste the resources. So this wastewater is can be used as a good source of resource for sustainable development. So here worldwide majority of wastewater is neither collected nor treated, or wastewater is valuable resource. but it is often seen as a burden to be disposed of. So this perception nowadays need to be changed, and 80% of the global wastewater is released to the environment without adequate treatment. So here, what we can get from the water. So the wastewater is basically from the three basic industry, that is from the homes and industries and some agriculture sector. So all these sectors are contributing for discharging more number of chemicals. It will be organic. It will be organic molecule. It will be the molecule. So according to that, which can be used, this water resources, wastewater resource used as one of the source or one of the resource to get the different types of the energy, some raw material, then for irrigation, means water reclamation, and the water reclamation nowadays, and recreational use and other things, and also for drinking water, as a drinking water. Other in a sludge, there are many things are that which organic matters are there, can be used for energy generation, it form of the gases and some bio-related gases molecule, and some inorganic important nutrient like phosphorus, and these can be used for the agricultural application. So here, so in this way, now we can reclaim or we can use this wastewater as one of the resource to be changed, and that is will be very beneficial. So these resources can generate additional revenue streams for the operator and paying part of all the operation costs, thereby contributing to the sustainability of the water system. So let us see how we can go. So now it is time to see wastewater as a resource. It is not just a wastewater as a resource to achieve the circular economy. So this is very important that I have shown here again. This is one image that's showing wastewater is the resource. So industry, households, and cities, and some other agricultural lands where the water is maximum use of water, and after using that water, it become not a water, it is the polluted water or somewhat used water, we can say it. So here, what are the sustainable development goals? So as you know all that, there are the 17 sustainable development goals that is adopted by the US United Nation in 2015, and they are targeted and they are expecting by the 2030 the whole world will be the very good of the air, water, and some all other as per the 17 SDS system development. So what are these goals? So I will not go in detail of the all goals. So our one of the goal, and this goal number 6 is about the every ensure the availability of water, means everyone should have the clean water and sanitation on this earth planet. So according to that, which one is for the water? So this is 6 number for water. What is mean? It means that this all peoples or animals or every thing on this planet will be have equal rights to get pure and good quality of sanitation. So this is about that. So what it can be achieved? How what initial or what new action plan to be need to be taken? So this is about the how we can go. So this is about the circular economy. So afterward we will go in detail about the circular economy. So here I have this is diagram showing the about our focus is about water, that is goal number 6. So here sustainable development goals about water. So what should be the action plan? So there are 3 R's. So the first R is about reduce the use of water. Second is the recycle user and regenerate. So what do you regenerate? So water is just water is not anything that is some ions and water, but some other sources of water like some other resources from the water are containing so many organic and inorganic impurities that may be hazardous one or may not be hazardous one, but we have to focus on that, and that is according to circular economy. So by considering this thing, it should be the according to sustainable development. It should be the very not to be costly, and some other aspects of sustainability we'll see in next slide. So what are the steps in development of sustainable water treatment? So our main focus is I am analytical chemist. Basically I have worked on the most of the aspects of the analytical chemistry, and separation is one of the technique that can be employed for the water purification. So here we can see that these are the different. This is general diagram. How we can get the this is already mentioned in last slide. But firstly, you should know either you are analyzing the water. Analyzing water means there are different types of water. Wastewaters are there, industrial wastewater, agriculture waste. So we should know the what is there, what is inside that water after they are discharging or before discharging into mainstream, that river and sea. So we have to need to know what is there, either organic, inorganic. Then treatment by means of sludge dewatering, or so many techniques are there. This is just example. And then sustainable recycling. So here sludge and some other loculated and wastewater effluent plants having number of stakes. I will not go in detail. So here these three steps are important to achieve the circular economy. So we can reclaim the water, we can use the sludge as a fertilizer, as a compost, and so many other energy and other things can be drawn from that resources, and it will be according to the sustainable development goal. So let us see. Just a minute. So let us see the difference between the linear recycling and circular. So as you know that we are talking today about the circular economy and zero waste. So recyclability is about everyone is know to you what is recyclability, what is cyclability, upcycling, all these things. But this is somewhat slightly different from the recycle economy and circular economy. So these are the two diagrams are same, but for the sake of simplicity, I have put both the diagram. So here in linear economy, we can say we have to just take and make and use and throw out. This is just linear economy. We can take the polymer, make mobile, and waste making waste, or using water, and then water are discharged into some systems like river, etc. But in recycling, in effluent treatment time, some water are reclaimed by recycling. So this is the recycling economy. First is linear economy, recycling economy, and third one is circular. So what is circular economy? In circular economy, most of the time, it is not 100% possible, but most of the people, as per the USB SDS goal, they are trying to achieve the 100% circular economy. So here there is no any waste. So some waste will be used as some for other applications like that. As you know, all of that, sugar industry is one of the best industrial example that is about the sustainable, as following the sustainable industrialization. So sugar industry, bagasse, and other byproducts are used. But similarly here, the waste after the some sort of process, or after some process in chemistry or in some other organization, so that should not be the waste as on this environment. So this is called as circular, and that can be value added product, that is called as resources. So this is about the difference between linear, circular, and recycling economy. So let us see one example, that is conventional method. For example, in wastewater treatment plant, there is electrocoagulation is most commonly used processes by electrical current. So coagulation fluctuations simultaneously happen, and there is formation of sludge. So that sludge contain the inorganic, organic impurity, and that can be recycled many times. So in another case, we can see the in circular economy. What this process will be the as per the circular economy. This process as per the circular economy, which will be the catalyst or the solid sludge cannot be wasted, cannot be dumped in the environment, but it will be the used as a again for wastewater treatment. We can make something from that, or we can use for other industries or other applications. But that it depends on the which type of pollutants or that material have. If there are some other impurity like mercury and some other hazardous, it cannot be used. So that depends. So that's why there is very tremendous, or people are this is a hot topic of research nowadays from the 2021. Now this is, I hope you understood what difference between the conventional method and circular economy. Now let us move to the next point. So how circular economy changes the water industry? So this is we have discussed it, but I have given in more detail. So here, if there are the different sources of water, groundwater, surface water from river, we are using, and from that after using, water become a wastewater. It contains some other impurities, either organic or organic. So it may be the how these circular economy of water in this helps to water industry. We can say here the biol, syngas, biocoal, some microbial fuel cell can be generated, some other salts can be recovered by biogas production. So all these are the just schematic presentation, but each and every sector or every sludge or any wastewater is not possible to give all these, but that can be considered hypothesized in the hypothesis. So we can how circular economy change the water industry. So this water industry again, if we consider specific job and other related stakeholders, how they are benefited. So they are benefited very, and there is one important thing need to be considered in circular economy. Most of the people, as we can see, the way we can clean the Ganga and all this. It is about the centralized water purification system. So here we have to in India or in or all over the world, it should be the decentralized water systems that will be more beneficial to get the more and more polluted free water in the environment. So this is the again how the water circular economy is helpful to getting job and some other related sources. So now, what are the barriers to implement this circular economy approach in wastewater or water treatment plants? So here we can see the wastewater treatment plant is associated nearby industry or nearby the municipal in the nearby the city to treat the wastewater before discharging to the environment. So here these are the various types of organic inorganic materials are available with that water. But obviously by following the circular economy, we have to complete the loop. This loop is very important. It is not just recycling one or two time. There should not be no secondary waste will be there. So what are the barriers that are the technological barrier? So these are the technology barrier. For example, I have adsorbed mercury with carbon. I have to first remove the all mercury from carbon, then use for this carbon again for the other application and all other thing. Some regulatory affairs are there. Some pollutants are very strongly adsorbed or binded to the during water treatment technology, so that cannot be removed. During some treatment technology, for example, membrane treatment technology, there are some polymers. So these polymers cannot be used but recycled, or sometime can be used, but there are limitations that depends on according to the polymer to polymer. Some organizational barriers are there. Organizational barrier. We can see some limited facilities and on all other things. Social barriers are according to the social impact, and last one economic. Suppose we are getting water 20 rupees per liter or any other water 10 rupees to liter, but treatment cost is more than that. It not be feasible. So that should be considered during implementation or during applying the circular economy approach for the wastewater treatment application. So this is sorry. This is how can there are barriers in everywhere on this planet for the water waste. So here how to achieve high circular economy? So this can be achieved. So we can see here resources, production, residuals and other thing. But in circular approach, this loop should be completed. So what is main thing? Reprocess is a very important tool. So that I have given example of polymer and some other thing. Some things are not stagnant, or that will be disturbed, its original structure will not be damaged. So many things are that depends on either people are working on catalysis, on membrane technology and adsorption. That depends technique to techniques. But here to complete or to remove the barrier, we should have to achieve the maximum or high circular economy. We have to think about how this loop or still applicable. Even COT now COT is nowadays one of the green solvent as per the supercritical fluid, and other gases can be used, but some other gases cannot be recycled. So this is the loop we can see here in red. So main issue is closing the circle is the reprocessing and reuse it. So that's it. So for that we have to use the technology. What we have to start. So during starting with one procedure, we have to keep in mind how we can go. So let us see. This is about the barriers. Now let us see what are the basic treatment technology. So methods of wastewater treatment there depends on the water is either simple water, river water, or it is wastewater. So these are the conventional advanced techniques are available nowadays in market, and some traditional biochar based methods are available. So here advanced techniques are classified into chemical, physical, biological, and energy based. So they are EVN. That depends on water is reclaimed for drinking water, drinking application, or other things, or potable water. So here this selection of the methodology for treatment of water. So it depends on the characteristic of water, quality of water, treatment efficiency required to meet the drinking water standard. Means drinking water standard, there are different standard as per the in India we are following the BS, Bureau of Indian Standard. In some country as per the WHO we are not following some rule, because US standard means WHO standard are very high. EPA standard are also different. Another one is the types of pollutant present in the water and treatment cost. This is very important. So treatment cost is important, as you know that alkaline water is nowadays boom. So alkaline water is just the electrolysis, but it is taking too much cost to pure the 1 liter of water. So many things are there. We are thinking about the wastewater more efficiently, because our main focus to use the resources that is from the different types of wastewater. So here let us see. So what is the main technology nowadays scientists or researcher are implementing. So as we know that emerging technology, apart from these traditional technology, or there are some advanced technology, contaminated water contains the number of impurities are observing. For example, nowadays microplastic is one of the big issue. So our group is also working on microplastic removal. So very difficult to absorb by carbon treatment technology, very difficult to trap or absorb on the surface of that adsorbent, or some other personal care product like personal care product which contain the more PFA containing impurity, all these things. So combinedly, physical, chemical, biological, sometime combined or hybrid or composite nanomaterial, composite materials are used or have been used by different scientists to get most efficient separation of that impurity and to get the clean water. So these technology can be utilized to achieve the circularity, that is called as hybrid or composite adsorbent or composite materials. So and let us see how we can achieve this. So here again I have given one diagram, so that is very clear about your idea. So before starting the circular economy, we should know the sustainability goals. So what is sustainability? So three circles are here. So this, what will be the we are developing or we want to do on this planet or in organization or industry. So there should be the social progress, or there should be social importance. There should be economically means affordable one, and this should not be hazard to environment. So that is called as sustainable development. So in laboratory we are trying to develop anything with respect to, there are different researchers having different types of the research area. Some are working in catalysis, etc. But here you to what are the resources we can found from the wastewater? So these are the industry, residential, agriculture water. So all these sources of wastewater I have just shown for your understanding. This diagram already there. So our focus is what will be the sustainable wastewater treatment technology that will close the loop of circular economy, or we can achieve the maximum circular economy. So that is the, so here such water contain nutrients, clean water, maybe clean energy can be produced, or so many things. So here before starting the any water treatment technology or developing any material for water treatment or technology, we should have to keep in mind this should be the maximum close the loop during circular economy treatment. So now I will come to a topic. So this is about the some part about how and what are the limitations of the existing technology and what need to be done as per the sustainable development goals. Now what are the hydrogels? So as you know that these are the different types of the polymeric materials are available on this Earth planet. Most of the polymers are associated with the biopolymer, and some are the synthetic one that is made by the man for different application as per the need. So here, why hydrogel? What are the hydrogels? So hydrogels are the three-dimensional polymeric material synthesized from either use of synthetic polymer or use of the natural polymer, having a capacity to, these are the gels, and having capacity to hold or uptake maximum number of water. So this is the what is hydrogel. So these hydrogels make an advantages in wastewater treatment technology via circular economy approach. So here what are the characteristics of this water? These are the some functional groups can be added by using the pillars or functional material, or itself one. For example, some biopolymers having COH and NH2 groups are there for interaction of the with pollutant. Cross-linked network would get the more porous structure, architecture, then surface morphology because of three-dimensional structure, it having more maximum number of surface and so on. And this is about the pristine types of polymer. When we add other some materials like additives like carbon, graphene, and other things, we can improve the of that by hydrogen. The rule of that biopolymer. So biopolymer will be natural one or will be the synthetic one. So that is not important here. So that should not be harm to the environment. That is called as biopolymer, or less hazard to the environment, or degradable environment naturally. So here these are different classes of the different types of the polymer. That is, some are derived from the plant origin and some from the animal and some fossil fuels, etc. So these are different types of chain carbon types of polymer. All other classification are given here. So here important thing is that these polymer having capacity to hold the water. This is very important to making or select the water for the select the polymer for the hydrogel manufacturing or synthesis. So here what is roll up? So I have last slide I have given these are the hydrogel, but these are clear hydrogel having no any additives and some other adsorbent are there. So in this case, you can see here what is roll up additive. For example, I have some hydrogel and not capable to absorb some impurity. For example, I want to absorb the pharmaceuticals are very difficult to absorb on the carbon also, and some other some other types of pool that is not easily attached as like as dye. So here we have to modify the surface property, modify the nature of its characteristic and some surface structure and some other properties. We have to add the some functional material. So that depends on your application part. So here we can add carbon materials, different types of graphene oxide. We can add the zinc oxide. Suppose someone is working on the catalysis, photocatalysis, he or she can add the photocatalysis inside the material, so that can be trapped very tightly bound, because these are the cross-linked material that is not just loosely bound the bonds in the material. So here functional materials are different types that are the but these addition of this functional material is very important. If you are achieving the goals, circular economy goals, we should your functional material should be the environmentally friendly one, or it should have minimum hazard to the environment. So this is for, so this can be, I have shown here, this can be in the form of beads or in for any shape. We can make the films, for example, bio-related application. Some people are using the wound healing application, and some for treatment application we can make is like a resin balls, like that is used in cation ionization resin. So here this can be used simple or hybrid, that per requirement. If simple is working, you need not to add anything functional. So that is the what is reagents, sorry, what is role of that material or agents or fluids are important during designing of the sustainable hydrogen. So let us see example. That is one example. So this work is about the addition of the this is calcium alginate based sorry, sodium alginate based graphene oxide composite hydrogel. So here we can see after the addition of the graphene oxide, the functionality of the change. So how we can observe here? So here we can see here calcium alginate and graphene oxide. This is composite and this is pristine, we can say. So these are the gels, you know, the different beads are available in polymeric beads and in food application nowadays, hydrochlorides and all this. So these diagram clearly indicate that if you add the additives or functional material, the capacity can be increased. So hydrogel bead is the same, having a same size, but we can incorporate the functional material, so it can improve the capacity of that material, that is pristine hydrogel material, and we can say the sustainable hydrogel as a composite hydrogel. So having a more efficiency to doubled or tripled or more than that. That depends on the how much you are adding in weight percent or percentage into that particular polymer. So here these are the simple approaches how we should have the one polymer source, that will be synthetic polymer or natural polymer, and we can add, this is diagram from my own book, so we can add the carbon based material, and I have just this is the current type of topic. So here in general we can add any fillers and then cross link with that is called a gelation. So what is cross linking? So cross link is very important, otherwise the added material we can be cannot be molded into the form of like films or beads or hydrogel rods. So that depends according to application. And another one thing, that once it is cross linked, it is perfect bonding between the covalent bonding or coordination bonding takes place, and this bonding is very important for class. This is the calcium for cross linking of the alginate hydrogel bead. So this is the what is the role of important cross. So there are physical cross linking agents are there, some chemical are there, some inorganic salt are there, some organic molecules are there. That depends on polymer to polymer and what is your application, and hard and soft gels are required. That depends on as per requirement. Now these different forms of beads can be prepared, and these are the some structures. We can see the different, more than one polymer can be added. If you want the more properties, we can tune the more properties. So here this is one diagram that from my group. So how they can, this is example of the activated carbon that is added in the polymeric solution, and we get the cross link. So having hydrogel bead, this polymer sustainable hydrogel beads having its own cross-linking porous structure. At the same time, surface is full of the functional group, and that depends on the which type material polymer you have chosen and what is the pillars materials you have. So this is the circular economy hypothesis. Now this diagram clearly show that. So what is, so this first is about the synthesis of the hydrogel. So this is about the synthesis of hydrogel, and second is about the how it can be used. So here how it can be used for circular economy hypothesis, as per the hypothesis. This is a hypothesis. So here these hydrogels are, for example, chitosan are there, other polymers are there, and having different polymeric structure. So these polymer structure having some functional group, and we can play with that structures. Sorry, we can use these properties for different application. For example, in wastewater treatment technology during recycling study, we have to use the material more and more number of cycle. So this will be very benefited as per the recycling ability is more is the material, or more is the material capacity. So here we can change the pH. Some polymers are very sensitive to the temperature, that is called as stimuli. So it will be we can change the property or surface or sort of material as per the stimuli. So stimuli will be the pH, temperature, and so many other things are there. So most importantly, people are using the pH and temperature and some other thing, other characteristic properties, because it is very easily tuned because surface having either NH2 group or COH group or OH group. So this is according to the what is the hypothesis. So here in hypothesis for more detailed application, for real application, so this is the recyclable use. So these are the water. So in lab we are dealing with the one of the pollutant, that is model pollutant, but actually when consider the wastewater, there are a number of pollutants are there. So these gel having different property, recycle reutilization, because this is having different materials, added material and its own polymeric property, capable to dissolve the pollutant by using pH or temperature and again use for the same material and so on. However, this is not completely the circular economy. This is just the recycling, or we can say the number of, we can use upcycling. So this is the hypothesis we have chosen in our work. So more number of cycle also beneficial, we can reach up to towards the circular economy, but it is not like that. So let us start with my own laboratory work. So here we can see different. This is first article. Sorry, this is work. This is about the published in Journal of Environmental Chemical Engineering. So here we have a completely green and sustainable approach. So most of the drinking water treatment technology or industrial water technology uses carbon, granular carbon, or carbon beads or carbon shell to remove the chemicals or pollutant in water. We have used these materials and recycled or upcycled and then activated by physiochemical method, that is treatment with heat and some chemical, and we have added into sodium arginate polymer as a base or backbone of the polymeric material to make the hydrogel. And hydrogels are prepared by adding filler as a carbon, that is waste carbon, we can say the spent carbon, and this bead is used for the removal of the tetracycline, that is one of the model pollutant we have used for removal of the so for study of that capacity of that designed hydrogel. We can see here, so this hybrid hydrogel or composite hydrogel, so tetracycline material can be removed up to 50%, up to 10 cycles. So what is the things are here keep into consideration as per the circular. So here we are using the material that is waste from the RO plant. We are again using the in the form of hydrogel bead, and we are adding using this. So resources are used, and for polymer we are using resources of the naturally based deposit. Alginic acid are the source of sodium arginate, so that is naturally polymer. So here we are not purchasing any chemical, so not using any synthetic polymers or man-made polymers. So these are just the polymer that having importance in having nature of biopolymeric network. So here we can see this is the complete scheme, and we can see here they having a very good capacity as per the we have studied just with methylene blue and recycling capacity. So this loop is continuously up to the 10 cycle, and this material we can see here completely remove the methylene blue or any pollutant, that is what just study, but our main study is about tetracycline, that is one of the pharmaceutical pollutant. So here I will not go in detail about the procedure, that is just a schematic presentation, how we have implemented to treatment to optimize the get more and more activated carbon. Then this is methodology about the synthesis of hydrogel beads, and this is experimental optimization. So here we have to optimize the pH pit and all other thing, and number of amount of adsorbent required and all other things. So these are optimized by using the model pollutant. So here we can see the characterized material. So here, as per I have mentioned about the properties of hydrogel, it is very porous in nature material. We can see, so these are the A2, this D diagram is about the hydrogel, that is composite hydrogel. But when just we have used a pristine hydrogel, pristine, it is having no any carbon, just a sodium arsenate we also studied. So what happened here? So there is not much porous or rough structure, so that is responsible, maybe responsible, rough structure in hybrid material is responsible for the maximum absorption of that pollutant. So here, from that we can see it is the chemical modification takes place on the surface of hydrogel bead, and we can be used for as a water treatment application as a one of the adsorbent. So this is characterization for finding the what are the material, their nature of carbon and all these things. This is XID and XPace, that is finding the some raw material, what is the raw material in as a spent carbon, how much is there. For example, we have acted with phosphorus, we get the phosphorus peak as 2p, phosphorus 2p, and some other things. So here I want to mention that we can modify the material, we can use the resources for getting good things or getting good material for application. Now this is again characterization for making functional group. So this is about the this is about the experimental optimization. So here we have studied the concentration of tetracycline as from 100 to 1000, and this is from the amount of adsorbent. So 100 milligram is more enough, and time for the absorption is 48 hours. Maximum we can see the 24, but after 10 to 20% is increased up to 48 hours. So this is about the optimization of parameter. One important thing we have mentioned here is that we have not used any organic solvent because we are added with the sustainable development. So we have used here buffer pH 2 and pH 10 aqueous buffers, aqueous solutions, and to recycle. So what's that? Again, there is a acidic water will be generated after washing this, but this can be neutralized. There is no need of any wastage of organic solvent. So here, with this washing different solvent, we get the good capacity with warm water. So it indicates that no need to use buffer solutions and all of these things. So just warm water. So I have mentioned in hydrogel properties, we can modulate the, or we can play, or we can modify the property or use again and again by using the stimuli like pH or temperature. So that is one example here. We observed that is warm water or temperature can be utilized to recycle or reuse up to the 10 cycle or more than that. So we have used. So now this is lab study, and what about the application in real wastewater applications? So here most of the industries are and industries are having different pollutant, and for that practical application we have collected the wastewater from different sources because we are located near to the Surat, and GIDC and different types of industries are there. So we have collected the different application, different effluents, that is from industry effluent, and we have spiked with the tetracycline for getting how much it can be in water, because we are studied in distilled water, and for our application we have to check the capacity in a different water. So here we can see very good capacity is observed, and I have tabulated in the form of table in lastly. This is the industrial wastewater. This is pond water. Again, it is not just industrial wastewater. We also studied with the real water like for a river, tap water, and we have good capacity to remove the tetracycline pollutant from the water. And here we are, this is the diagram for without adding any tetracycline or any model pollutant. We want to change the capacity of designed material, how much it can be absorbed, pollutant absorbed by the material. So these are the results of the study, and we can see here the different material can be absorbed different dye. And apart from the studied model pollutant, we also studied the other dyes like methylene blue, that is most commonly used, and some other organic molecules. So overall, we have checked the industrial wastewater, real water sample, and some other pollutant, or we cannot say pollutant, some dyes and other having different functionality. So this is the table indicate that we have got the 300 or up to the 400 milligram per gram, means 1 gram of metal absorbing the 396 milligram of the tetra, and is very difficult task for the pharmaceutical. We can see from the table it is very difficult to absorb. So, and again another one is paper is about hydrogel. So it is having a 544 milligrams. So these results are indicating, so most of the hydrogel materials are capable to absorb. So all these are hydrogel. We are compared the result, but addition to that, we have studied the sample by spiking and just simply checking the capacity for the other pollutant. So another one scheme is about the use of agriculture. This in India there is a vast residues of agriculture that it can be used as cattle feed, but some feeds cannot be used. So some part residues are used. For example, maize. Maize stock we have used for making carbon, and we got very good carbon structure like graphene sheet like structure, and that we have incorporated into the polymer. So that is we in this case we have used both two type of polymer, gelatin and sodium arginate. And again, so here in last problem we have just recycled the material and then used for different application. But as I come across to different application as per the circular economy, we have to close the loop. So here these application also extended for industrial wastewater application, but here in this case we have used doxorubicin as a model pollutant. So this is just a drug that is model pollutant, that is anti-cancer drug most commonly used for anti-cancer cancer treatment. So here what we want to say, after 10 cycles similar is the study, but what about this waste material? So this waste material as per the circular economy approach we have studied are used as a fertilizer, because we are using both the polymers here, double polymeric network hydrogel we have designed, which contain the agriculture residues as a carbon. Here we not used any chemical treatment for to making the this carbon, and finally we get the very good hydrogel capacity of hydrogel. But after 10 subsequent cycle, the cycle again decreases because pores are filled, outside, and so many things are there. So what this material? So that is how to go for zero waste. So this waste we have tried or we checked for different adding with a different percentage. So first is the control, second is the 0.1, 0.5%, 1%. So we can see here there is a very good capacity we observed for the that application. So what that application? That application about the to close the loop and use this as a circular economy and zero waste approach. So I have given in detail. So this is how to synthesize the carbon. I will not go detail because there is less time to me. This is about the methods again same. This is characterization of XID and same, a very good plaque-like structure we observed for that carbon graphitic structure. This is the how this builds. So this diagram is about, again we can see this is pristine hydrogel and this black containing the carbon. So this carbon is very important. That means fillers are important. Polymeric materials are not capable to absorb more number of the pollutants or more maximum number of the pollutant. So here mechanism, recycling mechanism, here we used a buffer pH to getting, because there is gelatin and that might be the NH2 group will be the dissolve that drug and again used for the different. So here I want to show here that so this is the recyclable study. So here again with the consideration with others. So this is first report and that is recently published accepted for Langmore, publication Langmore. So here we can say that this type of mechanism, so this type of study need to be explored more for practically from lab level, then pilot scale level. And so here again we have studied the different types of industrial effluent with addition of doxorubicin hydrochloride as a model pollutant, and we have got the very good capacity. These are the UV spectra for that absorption after the after using different avenues. So here another one important application is that, so most of the industry deals with the COD. What is COD? Chemical oxidant. That associated with the how much organic matter is there. So how much? So that will be a hazard to the environment. So here we can see here after the doxorubicin, this treated water with adsorbent hydrogel, we have the half of that CO2. That means this material is very useful and can be implemented for wastewater treatment application. So on lab level, we studied this COD and COD is very good, and half of the COD is decreased. So that is it means that apart from the other application, it can be used for the organic pollutant. So organic pollutant is about the how we can go for the removal, and that is just with COD and BOD. BOD is somewhat different thing, but COD we have studied here and we get the very good capacity. Now I will not go in detail. Some more applications are there. People are, so what they are did here. This is just take one application for hydrogel application. So here Gore gum is one of the naturally polymer available that is added with titanium dioxide is most no material for the catalytic application, and make hydrogel of the Gore gum with TiO2, and this hydrogel having capacity to absorb the methylene blue and at the same time cut down the methylene blue. Cut down means cut degradation. So there is double role, and it is very good work. This is not my work. That is some I have taken from Santos et al. And that is also recently published in 2021. So like that, people are trying to go with circular economy and avoid the maximum wastage of the water and discharge of the chemical into the water. So this is one example. Like that, drug delivery application not in the separation or wastewater treatment, but biopolymers can be used in such way that some people are now working with the membrane development by modifying some fibers into that, because membrane technology is very difficult to sustain at high pressure. These are the soft material. Now still there is question that I have discussed there. So still there is question is about the how we can close the loop. So these are the hydrogel beads of real images that is contain carbon and polymer, and this is after adsorption. So it finally conclusively indicate that there is change in color. It means there is some pollutants, there is some interaction are there, but still we are recycle up to 10 cycle. But what is the next use of that? How we can achieve the maximum or zero waste, or there is no invest in the environment? So as per given, this is just a detailed study that I want to show the pictures. So we have taken the mung bean that is most commonly available everywhere as a model seed, and we have used this material by sowing into the soil with 0.1%, 0.5%, but here we have used the used after 10 cycle, after the 10 cycle, the material of the hydrogel composite are used in the form of powder, then added into soil, and we get the results. So results in your on your screen. So we can suggest that as per the circular economy by the USA or by the SDS goal, we can use it as a fertilizer. So this because it contains the biopolymer, it having carbonaceous value, and the added, even though this is chemical molecule, that is we have used doxorubicin and other molecules are there, but these contain the carbon. But in case of mercury and other things may not be used, we have to remove it. So these are the some limitations. So for organic pollutant we can use it. So these are the limitation of this study. So on 70 day we have the goods and they are not decreasing any. This is just for cytotoxicity we cannot say, but just to check the hazard's nature and to complete our study as a zero waste. So we cannot generate, we have not generated any waste during the development of our protocol. So this is about from my side. So yeah, this is my lab at Narsingh Institute of Chemical Science. Basically, we have the dissertation student at last year, and I have 4 students for PhD, and 1 is submitted. So this is a lab structure, a very good lab structure at Narsingh Institute of Chemical Science at Narsingh University. This is my university campus. Recently, in February, we have the conference. We can come. So here, I'm very much thankful to DST. I have one project in past, and I'm thankful to the TA, Narsingh Institute of Chemical Science, Narsingh University, and I'm thankful to the Dr. Abhijit and some other organizer members and principal of the Wilson College and whole team of the Wilson College that is they are organizing such type of conference for improving the sustainability and to achieving the most green environment, sustainable environment. Thank you.
Thank you very much, Gore sir. I observed that you was not well from morning, but because of the personal relation, you are giving the lecture session in this today's national conference. I observed that.
Yes, sir.
Thank you. Now this session is open for the question answers, online as well as offline participant. You can ask the question. One of the question is there from the online. It was informative session by Dr. Anil Gore sir. What is the difference between circular economy and zero waste, or are the same?
Actually, these are somewhat different. Zero waste means we need not to go for the circular economy every time. For example, you are doing something and we are not generating any waste, so that can be considered zero waste. But we are doing some waste, generating some waste, and we are recycling again and again, or for other application, we can consider as a circular economy. Because if waste is generated, then and then we can go for circular application or circular approach. Okay. And every economy approach is not a zero waste. So that's why I have given there is people are troubling for the complete the loop.
One more question is there from online participant. How much time is required to form hydrogel?
It is just 5 minutes, means we consider the gelation time. That depends. Suppose we are dealing with calcium chloride, and it is more enough time. Like for example, 3 hours is more enough to get completely cross-linking. But at the time of when we go with the extrusion method, we have the only just 1 minute or more than less than that. But after the making or formation of bead, it will be kept in the mother solution to get complete gelation. Otherwise, structural property will be we observed that our structural property will be damaged after subsequent, or if you are using for a subsequent cycle, or some inside filler can be released.
Hello.
Hello.
Yes,
Hello.
ask the question.
Can I? Yeah.
Yes,
Can I
Ranveer
ask
sir.
a question?
Ranveer sir.
Yeah,
Yes,
yeah. Yeah, Dr. Gore, it was a very nice talk by you.
Thank you.
And
Thank
it
you,
was
sir.
a very informative talk, and you explained very nicely about the circular economy. So I have one question. I'm basically I'm basically a biotechnologist, not a chemist.
Yes.
But
Yes.
but I would like to know that these hydrogels, which are basically you're trying to use from the natural substrate, you made the natural material. So ideally, it is going to absorb the pollutants from the wastewater. Okay, and then basically many of the pollutants are toxic. And as you mentioned, the doxorubicin, basically, it's a very toxic and carcinogenic molecule, and it's a cardiotoxic molecule. So when you are trying to remove the pollutants from wastewater using the hydrogel, and it is getting absorbed onto the hydrogel, such toxic pollutants how the eventually these gels are being destroyed. I mean, basically you need to get rid of the pollutants eventually. So my question is that, I mean, it's fine, you are trying to adsorb and trying to remove it from the wastewater at certain level, but then eventually it is going to remain in the gel and trapped into the gel. And especially the molecules which are toxic, how to get rid of that eventually. And it will not be advisable to use such a hydrogels for agriculture application, because the toxic molecule can enter into our food chain. So I just want to know from you this.
Yes, exactly. You are right. Actually, we have not studied the what is the toxic effect. This study we will consider in. We are planning for that. Just growing the plant, it is one of the just study to know the it is toxic or not. But sometime it will be toxic, not to the plant. It will be to as per your. So here, we during separation we have the buffers, and suppose we are treating the water. For example, most of the water sources contaminated or that is stored in water tank. So here, important thing is that hydrogel beads or there should be some residues of the what will be the pollutant is there. For example, in case of doxorubicin, there should be the doxorubicin, but there might be the some extraction process will be required to remove that or other material, because firstly we have to distract that material. So extraction is required. So it will be very costly technology will be there, even though from the membrane technology. So for that we have just checked the toxicity. We cannot say, but it's a hazard. But it so it might be the there, but we are planning to study with like sub cell line and some biological person.
Okay, sir. Because of the time constraint, we'll not take the next questions. Sir, your work is very appreciable. We observe that some of the papers has a high impact factor, more than 10 impact factor, and this your work is very useful for the in the agriculture sectors, because of the farmers when is tree or plant or crop require the water, because some of the area there is no water, but water can give in the form of the hydrogels, and hydrogel have the capacity to store the water more than 15 to 20 days. I think this is very commendable work, and you develop your already you are developed one filter for the purification of the waste water. Sir has given the talk on the sustainable hydrogel for water, wastewater treatment, circular economy, and zero waste approach. Sir has enlightened the points in this talk. Sources of water pollution. We have to change the perception, need to be changed waste to resources. Steps in development of sustainable water treatment for the technologies. Sir has given the relation that linear versus recycling or versus circular economy approaches. Relationship between the circular economy in water, wastewater treatment. Sir has enlightened recent treatment techniques for water or wastewater treatment. And he has given the what are the hydrogels, how hydrogels are responsible for the sustainable development. Then role of biopolymers in the field of sustainable hydrogels, preparation and optimization of hydrogels, and what is the important is sustainable composite hydrogels in application in water treatment, and whatever the last adsorbent disposal, circular economy and zero waste water approach. Sir, thank you very much for this enlightening session. I'm very confident because here is the research scholars. I think they will think about when you are doing the research about the innovative and application-oriented research. Once again, thank you, sir, on behalf of Wilson College Management, Principal, Convener of this conference, and all organizing committee members, as well as participants from the Maharashtra and out of Maharashtra. I think we'll take the lunch break, and thank you once again, sir, as well as participants. So those who have the oral presentation or poster presentation from the different sections, they have to join at the 2 p.m. because we reschedule the timing for the presentation 2:30 to 2 p.m. Thank you.
Okay. Thank you, sir.
And we can use the same link for the yesterday's for the all the different sections for the presentation. Thank you, Gore sir. I think.
Thank you, sir. Okay.
Okay, that link is posted on the group. Please, you can use that presentation links.